skies. Feel like I'm wasting all my time. Why can't we all just play pretend and act like school already ends? Maybe if all the leaves were green, I wouldn't spend my days asleep. I'd wanna take in everything and feel the air upon my skin. Why is it so hard just to have a good time? The sunny days come back in. Things are getting hard for me to decide. The sunny days come back in. Don't feel alright to say the least. I know this isn't only me. I wanna give my everything, but I just mope around and sit. I wanna go out happily, running with grass beneath my feet. Can we just pretend it's summertime and we're laying in the rays of sunlight? We could have a very good life. Maybe I'll be happy all the time. I want the summer and blue skies. Feel like I'm wasting all my time. Why can't we all just play pretend and act like school already ends? Maybe if all the leaves were green, I wouldn't spend my days asleep. I'd wanna take in everything and feel the air upon my skin. Why is it so hard just to have a good time? The sunny days come back in. Things are getting hard for me to decide. The sunny days come back in. Why is it so hard just to have a good time? The sunny days come back in. Things are getting hard for me to decide. The sunny days come back in my mind.
I guess you could say I'm totally fucked up.
Where'd you go? I just wanna look in your eyes. Caught up in your feeling. different with me. I guess it must be hard for a guy to look up in the eye when the speed is giving you what you need. You know I've been fucked up, crazy. It's been a little heavy, but you're the only one who can save me. I know that isn't fair. I know that isn't fair. Why is it not always open? Why is it not always when the red lights go? But I'll be yours until the morning. I'll be yours. I know that isn't fair. I know that isn't fair. Don't close your heavy, don't close your heavy eyes. Darling, you have so much to leave behind. If you travel to the other side, darling, I'll be right here holding your hand. You taught me how to be a real man. I'll be right here holding your hand. You taught me how to be a real man. Yes, you did. Yes, you did. Yes, you did. Maybe I'm selfish, don't know the pain deep inside. Darling, you put up a damn good fight. If you travel to the other side, darling, I'll be right here holding your hand. You taught me how to be a real man. I'll be right here holding your hand. You taught me how to be a real man. Yes, you did. Yes, you did. Yes, you did. Yes, you did. Don't you leave. Don't you go, Doris. New Orleans Club, the legacy. Don't you leave. Don't you go, Doris. New Orleans Club, the legacy so strong. Don't you leave. Don't you go, Doris. New Orleans Club, the legacy. Don't you leave. Don't you go, Doris. New Orleans Queen, the legacy so strong.
Good afternoon. Oh, this works. Awesome. I have notes because I've been given instructions to say this and that, make sure that we thank our sponsors and everything. So I'll do that right now. Thank you, Cassandra, Portworx, and our media sponsor, Evaluator Group. Where is Evaluator? There you are. Hey. Bienvenidos a todos. Good afternoon, good morning, good evening if you're following online. I heard that we have a bunch of people watching this online, so this is awesome. Welcome to yet another Cloud Native Data Management Day. Can you all hear me? I can hear myself, so we're all good. I'm Tim Layden, work for Cassandra. I'm going to be your host today. I know nothing about Kubernetes, but a good thing I have a lot of smart speakers to share everything they know. Super excited to be here in Valencia. A lot of great folks, a lot of cloud native enthusiasts, a lot of Kubernetes communities enthusiasts. Not the worst place to be. I like tapas, I like sunshine, so where else would you want to be, right? I love this place. For those who are attending CNDM Day for the first time, a few words maybe. CNDM Day, Cloud Native Data Management Day, was designed as a community effort for people who are eager to learn more or to share their knowledge about Kubernetes and cloud native data management. We welcome users, developers, we welcome vendors as well, and anyone who just wants to be part of this community. I've thanked the sponsors already, made sure to do that so we can move on. I was asked to share a few housekeeping rules or just information. Restrooms. That door outside on your right, which is my left, that always confuses me. Also, in case we need to get out of here, I think that is also the fastest way. There is a stairs there. If there's an emergency, don't use the elevator. You all know that. There's going to be food and beverage in the back of the room as well. I hope some coffee is coming because I would love some coffee. And then any one of you who wants to share some of their ideas, ask questions, please do. This is supposed to be an interactive event, so raise your hand. Lynette over there has a microphone, so we can make sure that people online can also hear questions. That would be great. So collaboration, community, content, that is what it's all about here. And fortunately, we have a lot of great guests and speakers here. I would already like to thank everybody who entered speaking proposals and abstracts and whatnot. Those of you who cannot present right now, please keep entering them. We have more CNDM days coming up later. The next one is going to be in Berlin in June, and then we're going to have one at the next KubeCon as well. So again, super excited to see so many of you in the room, to see so many people online. This is really going to be a great event, and the event is not about me, it's about great speakers with great content. So without further ado, I would like to present our first speaker. He's not new to CNDM Day, he's been here before a few times already. Alex is founder and editor-in-chief of the New Stack, and he's here to share with us what's new at the New Stack, what's new in the ecosystem, what he's been seeing, and I'm very sure that he's going to be happy to answer a few of our questions as well. So, Alex, why don't you take it from me and entertain the audience?
I'm just going to open up my laptop here and just hope it works. I'm sure it does. All right. You all set? Oh, there we go. Let me just put this in slideshow mode and we should be off and running. I'm going to go back to the first slide and we'll just get underway. Well, good afternoon, everyone. It's so great to be here in Valencia, Spain. I'm Alex, and so wanted to just give you an idea of how we think about the community right now, how we think of where the trends are. And I think it's really reflected in our reader survey and some of the top posts that we've seen over the past month and past week. We've been tracking more closely the posts that are doing well. So what I thought I'd first do is give that reader perspective about what is interesting to them, and then we'll get into a little bit of the stories that we're seeing that are popping up of interest. Please feel free to ask any questions if you're interested in trends that you're curious about, but what we're seeing, this is a chance, I think, for people to get ideas about maybe their own blog posts or maybe some confirmation about direction and trends and such. So look forward to your questions. So we do an annual reader survey. We start the process in the fourth quarter, and we get it ready to present by the beginning of the year. The goals really are to find out, for us, who are the key audiences out there that we're really trying to target? What is the content that they value, and what is the topics that they prefer? It really helps us with our own editorial direction, and it gives us an idea of what we should be covering in the new year. This also helps our sponsors' content marketing initiatives, which really is done through contributions. And what you'll see here is a lot of posts by sponsor contributors. What we're really seeing is like a confirmation of the past several years where a lot of our readers are actually, they identify as back-end developers and architects. And one thing I think you'll see in some of these posts that I've collected is that connection between the web and the back end. We're seeing a lot more examples of that in the stories that we write as we see more companies and more communities start to adopt these practices. They want depth. People really are interested in wanting that in-depth stuff. So we really are putting a more focus on tutorials and that type of material. We're going to be publishing ebooks, for example. It's really good, I think, lesson not just for us, but for I think anyone who's in the business of or just has part of their job responsibility to develop content. It's really a way to gain visibility. And one of the things that I thought about when we first started the new stack was how are we going to get our name out there, and how are we really going to tell our story? And I just thought, well, gosh, what better way to do it than write blog posts? And that's what we do, and that really serves us very well. It helps us keep our engine going and interested in what we do. Kubernetes and DevOps are still the top topics of interest. I think we'll see that. That's really interesting too for us because it speaks to our own DNA. We really started focusing on container architectures back in 2014, and we still do that, and we still have that focus today. This survey was conducted in late November. You can see that the participants vary, but we always make sure we get enough good sample size to be able to have meaningful results. So we ask people what defines their role, and I think this is always interesting for me. We see developers and software engineers right up at the top, but we're starting to see some of some interesting corollaries. So one thing I always point to is DevOps. Now DevOps only represents 7.2% of the people who identify themselves as DevOps, but I think what you find is that a lot of people actually consider themselves doing DevOps work when they are developers or software engineers. And where do they and really what are they developing on? And look at that. It's like 69% are developing for the web and the back end, and 61% or so for the cloud. Server infrastructure, 38%, and then it goes down from there. This one way at the bottom is my favorite topic though lately, WebAssembly. And how many people went to WebAssembly Day yesterday? Did anyone go? Well, if you're unfamiliar, it's a fascinating time because what we're starting to see is with the evolution of container architectures and the evolution of just the edge, so to speak, we're starting to see a lot more interest in WebAssembly because it's very portable, it's very secure, and it's very, very lightweight. So I expect this will grow over the time. We actually called 2022 going to be the year of WebAssembly, but I think in terms of its real practicality and what we're actually seeing out there, it's actually very low. I attribute that in part to the dev experience that the WebAssembly has. It's just not that. It's just still very young. When we look at this, we always see, it was one of the interesting surprises for me when we first started the new stack was how many people actually said that they work for companies of very large size. And that's pretty much what we see year in and year out. That the people reading the new stack are really looking to this because they need that information. They need to have those insights and trends. But if you start adding up these different, these numbers, you'll see that there's some corollary though to like the top half, where we still see a lot of people who, if you combine like self-employed not working or people who have 2 to 10 or 11 to 15 employees, you start to see the numbers add up. So there's an interesting balance there. this is we always want to make sure that we're doing well in our work. And what we really focus on at the new stack is explanation analysis of at-scale development, deployment, and management. We really want to make sure that people understand what the topics are about. People need that explanation. They really need it to help understand, what they're doing. So for us, the news is important, but we don't live by the news like a lot of news organizations. So how are people using the new stack? They're staying informed of trends. They're getting the latest news. They're identifying new tools and services. We don't do a lot of like how-to kind of stuff, but it is actually in demand out there, and we might see more of that as time goes on. People don't really come to us for informing a purchasing decision, but I think there's kind of the corollary of informing a purchasing decision and staying informed of trends and getting the latest news and identifying new tools and services, which does correlate to something like informing a purchasing decision. Again, it's depth that people really want. You can see that people really want to see these tutorial articles. They want to see article series on specific topics. They want the detailed analysis, the case studies, the ebooks. So that's the kind of information that they're really looking for. Down at the bottom, podcasts. Interesting thing about podcasts is like there's almost like a separate audience for us. There's some crossover, but what we found is like a lot of people are just coming to us for the podcast. And I remember in the early days, people didn't even know that we had a site. What topics do you want to see us covering this year? DevOps, Kubernetes, GitOps, observability, cloud infrastructure services, infrastructure as code. And again, what I'm always looking forward to is to trying to understand, what about serverless and function as a service? Why is that not gaining a lot of popularity? Well, if you think about it, there's a lot of topics that are related in DevOps and multiple cloud hybrid architectures and Kubernetes that have serverless or function as a service components to them. So I think there's something to look at here and like getting an understanding of really what people are saying is like the top things, but understanding that there's a little bit more nuance and context when you're looking at some of the other topics that maybe not as popular, but maybe actually reflected in some of the topics that are of primary interest. If you look at what ranks in terms of interest comparatively, you'll see that Kubernetes has actually gone down in ranking, which is for us a sign that Kubernetes and containers are still of super interest. They're very mainstream now. But what we're also seeing is that there's a new interest in other types of stories, other types of trends. And we see that, for instance, with the kind of the integration of the back end and the front end, which is interesting. Other trends here that I think are of interest, like if you look at observability there, look at the jump that it's made right there from 19 to 6. I mean, that speaks again to the very complex architectures that you're starting to see emerge. Microservices are very complex to develop. You need something to go beyond monitoring the application to be able to do some observability on the components themselves. The declining interest, microservices and serverless, databases, service meshes, and so those are the ones that are on the decline. I again, I'm not so sure about the serverless one. I mean, I'm a little skeptical of that because I think it's integrated into a lot of the kind of work that people are doing. I think you may see some increasing interest with serverless and fast as we start looking at WebAssembly a little bit more. There's a lot of interesting stuff going on in that world. Microservices, I think people just have gotten tired of the term, but still the complexity is there, and the explanation of the complexity is important. This is one of the more interesting topics where you can see it by job role. I've always find this slide of particular interest, and what you can do here is when you look at the job roles that people have. For instance, I know a lot of you probably, maybe I should take a quick poll. It's like, how many people here consider themselves developers? software engineers, back-end architects. Okay. A lot of storage administrators, or I don't know. I mean, maybe someone can, maybe, is there a title that I haven't mentioned that you associate yourself with? Anyone? Oh, okay. Well, I guess I'm 100% on that one. So if you look at DevOps, for instance, IT management's not going to have as much of an interest in DevOps. But if you look at artificial intelligence and machine learning for IT operations, it's the #1 topic. This is a slide that we look at quite a bit to get an idea of what people are interested in. Let's get into the top posts and then we'll finish up. So we look at top 10 stories of the week and top 10 stories of the month. Here's kind of a look at kind of the stories, and I think there's some reflection in the reader survey results. So a new architecture for APIs was an interesting story about really the rise of GraphQL. Svelte has become extremely popular as an alternative framework, and we're always seeing a lot of interest in JavaScript. Best practices for microservices authorization. This to me shows a more advanced look at microservices and how people are viewing microservices now. They're looking for more in-depth perspectives on it. So, for instance, if you look at that article, one of the pillars that they describe is rollback RBAC, and so. I've been talking to more people in the CI/CD world about about rollback, and there's a lot of interesting kind of developments there using machine learning to do automatic rollbacks, because that's really going to be much more important as microservices get more complex. Some of the other stories in here, programming languages always do well for us. The 5 pillars of cloud architectures, I think that might be related to the headline a little bit. What is a microservices catalog and why do you need one? Again, it's interesting that microservices rank so low, but when you get into the depth of things, it's a little different story. AI development needs to focus more on data and less on models. We're hearing a lot of that. Platform engineering infrastructure meets the dev experience, and Red Hat embraces DevSecOps. And if you look at the top stories for the month, one thing that we do is, like on the weekends, we do a lot of cultural coverage, and so this comical coder envisions the worst programming is a great example of this. This radical story is another kind of example of, I think there's some more interest in decentralization. I think Web3 is such a volatile term, but this really speaks, I think, to the interest in different ways to kind of manage your development. And radical takes more of like an identity-based approach, which is pretty interesting. Low code, we're seeing more interest in that. Python, we're actually doing more of series like on things for people who are new to the world of programming. So Python, it fits into that. And then there's some of these others. I was going to just quickly look at some of these stories. So here's one. Here's a story by Anand. And this is again the new architecture for APIs. And Anand Jingran is super smart guy, and I would recommend reading this story if you're interested in how APIs are working. He kind of goes into, I think one of the most interesting parts of this article is how he thinks of GraphQL APIs as almost like this tree, as you can see. And he says, it can be, there's almost like these next level subgraphs that actually allow for a lot of different ways to be able to manage policy, for example. This is one of my example, I think, of like what we focus on such technical, serious type of stories, but we really think that there's the community out there is actually quite diverse. And this was a story about someone who did a let me look at here again. He did a comical coder story, and if you look at this. Let me get back to that. I love this. He says, Early on, Rendell turned his attention to Python, which calls generally very good and very reasonable, but then he displayed two identical-looking blocks of code, one of which throws an error because its white space consists of a mix of tabs and spaces. Annoyances shares with F#, Haskell, and OCaml. So Rendell's language took things even further. We're going to use 2 spaces for indentation, but if you're indenting by 4 spaces, then you use a tab. I just thought it was pretty, that's the kind of stuff that's actually very popular on the new stack, that kind of whimsical look at things. I thought this story might be interesting to the group here. It's about really storage as code in the next steps of for DevOps. It might be something you want to go check out. And what he's talking about is that there's this logical trend to follow the popular Kubernetes abstraction. But there's also this widespread demand for infrastructure to be generic enough for everyone to access what they need to build without having to bug infrastructure engineers all the time. And the story goes into a lot of the developers have historically had to go to IT to actually, ask for storage. And this is a step in a direction where maybe we can actually bring more DevOps functions into that whole process. This is not about code so much anymore. It's really about the people and how to make them put their best foot forward. I think I did 2 stories on that. Well, we'll go to another one. And, I thought I would just finish with this last example about how we're seeing just such a new interest in front-end development and how it integrates with back-end development. And this is a very popular framework, JavaScript framework, and it just, I think, reflects kind of the interest in the community to see more stories about how the front-end and the back-end architectures fit. That about covers it for me. Does anyone have any kind of questions about the new stack or a question I can answer about the stories? All right, well, thank you very much for your time. Oops, got it? Okay.
All right. Am I still on? Okay, good. Thank you, Alex. It was really interesting for me. What I'm remembering from this is containers and Kubernetes are getting into mainstream, according to your research. So that's really all good news for all of us. Our next guest is getting himself installed. I would like to introduce Rags. Most of you probably know him. Developer advocate with Datastax. And he told me he's got some interesting demos for us. So that's really what we want to see from our speakers, really getting deep into the caves of Kubernetes.
Absolutely. Thank you, Don. All right. So I've been tired of virtual for a long time. So it's so much nice to see people in person. And even if you go to sleep, that's fine. I really want to see people. I'm at that point. But this is probably my 5th, maybe 6th after COVID. So I was at a bunch of other conferences. I was lucky to attend. What did I start with? KubeCon North America. Anybody? KubeCon North America, Los Angeles. I know there were a couple of people there, Leonard, right? And and then I went to AWS reInvent. Anybody at AWS reInvent? Yeah? And the reason why I'm telling all this is because it ties into my presentation, actually. So I started off with kind of, everybody's talking multi-cloud in Kubernetes, but really nobody is quite doing it, right? So I was thinking I could do a multi-cluster, and turns out GKE was the easiest because I could set up the networking easily, and you will see, that's the hardest part of setting multi-cloud, right? The networking is the hardest part. So I started with that in KubeCon North America, and then when I went to AWS reInvent, let me make sure I have my power. Yeah, everything good? Let me start with... You getting my presentation or in there? Okay, one moment. Ein moment. Okay, so this is the time I can do some song and dance, right? Okay. Perfect. All right. So again, I don't want to kind of ignore the virtual audience. Thanks for joining as well. And good morning, good afternoon, good evening, wherever you are. So picking back from where I was talking, I was at AWS reInvent, and the GKE demo would probably not fly there, amongst the audience, right? So what I did was I tried to do something on EKS. And I came across this project called EKS KubeFed. Anybody use KubeFed, heard of KubeFed? Yeah, a few people? Okay. How many of you, by the way, are very comfortable with Kubernetes? So, I'm going to do a lot of demos on Kubernetes today. But I'll kind of walk through that. So even if you're not familiar with Kubernetes, you'll kind of get an idea of what I'm doing. So what I did at AWS reInvent was kind of adapted to EKS, right? But I really wanted something which was multi-cloud, right? And what I really wanted was to be able to spread this cluster across 2 clouds, at least, to start with. So I went again with GKE because I was very familiar with it. And then I went with EKS. And essentially what I was able to do was kind of join them together. But the process was entirely manual. I had to do a lot of things myself and so on and so forth. So finally, today, this is really brand new. I don't think I've done this demo before, so I might struggle through this a little bit, but essentially, what I've done here is we have introduced something called as a Cassandra operator. Okay, Cassandra is our version of Cassandra running on Kubernetes, and what the Cassandra operator does is it provides for multi-cloud installation very easily, and I'll talk about all this in a second. But using the Cassandra operator, this is going to be the whiz-bang demo for today. I'm going to use the AKS as the control plane. Okay, that's the Azure Kubernetes Services as the control plane. And then the GKE and the EKS as the data planes. So in other words, I'm installing through Azure, but I'm installing it on Google, and I'm installing it on, what's the other one? EKS, right? So it's pretty cool, and hopefully the demo will work. But I really want to thank a few people to actually make this happen. I think, Alex, you talked about kind of data storage as a service, or data storage as code. And actually, I've leveraged that in my demo as well. But before I get to my presentation, I want to put in a plug for Chris, who's here. Chris and Patrick, right? I'm going to be doing a talk on Thursday. This, unfortunately, Patrick could not make it here, so it's going to be all virtual, right? But there are already about 600 people signed in, right? So looking like a very popular session. Chris from OnDat and Patrick from Datastax, if you get a chance, please sign up for this. And obviously you'll get a lot more than just Cassandra, because it talks about local storage as well, and how you can kind of balance the two, talk about some access patterns and so on and so forth. And you will see a very short version of my demo as well. So if you go to sleep here, you can go back and check the other demo. All right. So what I'm here to talk about is, SQL, I talk about this kind of jokingly, is that Cassandra actually, precedes the cloud. There's no such thing as the cloud when Cassandra came along, right? Maybe there was, but definitely, the cloud got more popularity, more traction. And how Cassandra has actually evolved, to kind of support this is just amazing. And there are some really cool things that come together to make this happen. Okay, and I'll highlight this. I'll highlight all of that during my talk. So, I wanted to go just demos only, no slides. But when I saw that, a lot of you were not, familiar with Kubernetes and not developers, I thought maybe I'll do a few slides and then we can go from there. Okay, so this is kind of what I'm going to do. I'm going to keep it to minimal. Intro, NoSQL to Cassandra, Cassandra and Astra. Then the most important part, this is the multi-cluster cloud with the Cassandra operator. And then I'm going to do demos, okay? Demos are cool because, you will kind of watch me struggle through this a little bit. So hopefully it'll work, okay? My name, again, is Raghavan Srinivas, if I didn't introduce myself. I work as a developer advocate at Datastax. I really come from the Java side of the world. I've been a developer for a long time, really mostly a backend developer. One of the nice things I like, or one of the cool things I like to talk about is what is referred to as the inner loop, which is really about developer productivity. It's not the robust CI/CD cycle that most people are familiar with, but if you have heard of tools called Scaffold. Anybody heard of Scaffold? Anybody use Scaffold? Yeah, cool. Draft, unfortunately Microsoft stopped supporting them. Anybody from Microsoft here? May I make a request to kind of reinvest in that? But in any case, I'm really totally into developer productivity, and this is something that I believe strongly in. And even today, multi-cloud demo, I have some Terraform scripts. So if you want to install multi-cloud, you can do that. And I'll talk about that. What is the big deal about NoSQL? NoSQL is really not a big deal. It was really a catchy term that somebody came up with for a hashtag for a meetup. And that's how it became popular, because everybody was kind of sick and tired of Oracle, right? And just relational and all that. They wanted something fundamentally new, maybe easy to adapt to schema changes and things like that. And that's how NoSQL was born. Some people refer to as NoSQL, some people refer to as not only SQL, some people refer to as new SQL. But really the idea is that it's not the traditional relational that you know and hate, right? Or know and love, whatever, okay? So that's really what NoSQL is. And some of you might have heard of this CAP theorem. Anybody heard of the CAP theorem? So that I don't, yeah, or it's also referred to as the Brewer's conjecture. And essentially what it talks about is in a failure scenario, when everything is working fine, no problem, right? Everything works fine. But when something goes wrong, there are three properties, and you can only have two of these at the same time. In other words, you have to sacrifice one of them. One of them is consistency, the other one is availability, and the third one is partition tolerance, right? So turns out partition tolerance is actually worse than consistency, because partition tolerance, if you lose partition tolerance, then you're going to get into such an inconsistent state that even my grandmother can figure out that it is inconsistent. Whereas if you give up consistency for a little bit, it's fine, because eventually it will become consistent. So what if I'm not the leader for 2 minutes? It's probably okay. So what if I'm not the leader for 20 seconds, right? Even though 20 seconds I was the leader, it's probably okay. And turns out even some powerful transactions, right? You can deal with eventual consistency. There are a lot of companies that are using Cassandra, but again, the model is about horizontal scaling. You can take your relational database and keep scaling up and up and up, but at some point it's going to fall over, right? Because there's only so much you can go. Whereas with horizontal scaling, the idea is that you spread your data across commodity hardware, and that will take care of not only the scaling, but it also takes care of reliability and, of course, consistency and those kind of properties. So if you look at the NewSQL or the NoSQL ecosystem, they're usually called CA, AP, or CP. Okay, and Cassandra is like a AP system. Partition tolerance is very, very important. So some of the big companies actually use Cassandra. By the way, how many of you use Cassandra already? One. Okay, cool. Okay, and hopefully some of you will consider using this after just seeing these logos. And I've talked to some of these customers. They say that Cassandra keeps ticking for years and years and no problem at all. They haven't even rebooted. I hope they have upgraded, but never know. All right, what is Cassandra? Because all of us at KubeCon, right? It's really Cassandra running on Kubernetes. And like I said, Cassandra had a lot of desirable properties, which makes it very easy to run on top of Kubernetes. And actually, I'll go one step further and say that there were certain things that the designers of Kubernetes did not consider as heavily as much as Cassandra did, okay, or the designers of Apache Cassandra did. And I'll talk about that. One of the things, how many of you, by the way, have tried to set up a multi-cluster Kubernetes cluster? Anybody? 1, 2. Okay, and that's pretty cool, because I thought it might be nobody, right? But were you successful or no? That's kind of what I see, the trend. Someone over there? Semi-successful? Half? Good. What did you use for? Yeah. Okay. Gotcha. So a lot of these things you have to kind of, do it as a one-off, right? There is really not good ready-made solutions, and I myself as well, doing multi-cluster in Kubernetes is pretty straightforward, and doing multi-cluster with Cassandra is, even more trivial. The thing you have to worry about is how do I set up the networking, the routing, and all that. And I'm no networking geek myself, so I will point you at some Terraform scripts which essentially make this happen. It's a very opinionated implementation, but again, the fact is that Cassandra, or Cassandra in general, is really ideal for horizontal scaling. Okay, and we'll see that in just a moment. Since it's running on Kubernetes, right? Wherever Kubernetes runs, Cassandra runs just fine, right? And now with the Cassandra operator, you can have it on multi-cloud as well. I have it installed pretty much on all the, the different clouds. We use CEVO during KubeCon EU. Was it KubeCon EU? Yeah, I think so. It was KubeCon NA at Los Angeles, and we did a Cassandra workshop, which we used CEVO. So if you're going to use CEVO, you can do that, or you can use local installation. It doesn't matter. We have a lot of workshops, and what it does, in a sense, is it installs something called as a CAS operator. And the CAS operator does, all the Kubernetes artifacts. Let's not worry about all that. Kubernetes operators are really cool, right? Somehow they've become more, I shouldn't use that term, but basically they've become more trendy these days, right? There was a time when, Kubernetes operators was not the right thing to do, but now it's fine. And essentially, what it does is it installs all the, like for example, the things that you would do with Cassandra, like for example, repair, like for example, backup and restore. And we have a very cool API. I think, Alex, you were talking about GraphQL. Stargate provides not only REST, GraphQL, so it's really cool from a developer perspective. It also does gRPC, and name it, it's probably there. And then of course, Alex again was talking about observability. So you can send your observability metrics to Prometheus, Grafana, whatever. How do I install it? Very straightforward, right? Helm repo add and Helm repo update, and then Helm install. As simple as that, right? Very straightforward. I've already installed this. And what it does is it provides you with all of these APIs in Stargate. But if you don't want to use it in Kubernetes, right, or you don't want to manage it all yourself, we have this Astra DB, which is a database as a service. It's running Kubernetes underneath, but I don't care about it at all. It's multi-cloud, it's everything, but Datastax manages it for you, okay? And actually, it works on all the different clouds as well. All right, so the part that you're waiting for the most, right? Why multi-cluster? Cassandra has always been designed for multi-region, right? Partition tolerance was extremely important. It was, item number one, right? And then, of course, there are a whole bunch of things that we want to. Nodes automatically route traffic. We use something called as a gossip protocol. Gossip is good when it comes to technology, right? Because they can talk to each other. And as long as you have the, the ports enabled, the networking enabled, it's just going to talk to each other. And it's exactly what you're going to see today. I'm going to show it running on EKS, and I'm going to show it running on multiple clouds. But the fact is that once you have the networking enabled, it's not a big deal. It just works, right? The cluster is homogeneous from that perspective, right? So whether I'm running it anywhere else, it doesn't matter, right? But Kubernetes are not really designed for multi-region, right? And we saw examples already where some of our peers have been struggling a little bit, to kind of do this multi-cluster. But pretty straightforward. There are a number of reasons for this. I'm not going to get into that. But Cassandra operator is that easy button, right? If you think about the CAS operator, what it does is it installs Cassandra on a Kubernetes cluster. A Cassandra operator, which is sitting on top of that, thinking of hierarchies, makes it easy to install it on multi-cluster, multi-region, multi-cloud, as you will see today. That make sense? So this is the Cassandra operator, very easy to use. It's basically an operator for Cassandra. It supports multi-data center, multi-region, et cetera, Cassandra cluster. And what it does is it uses a concept of a control plane and a data plane. A control plane, as you will see today, is running on AKS, and the data planes are running on GKE and EKS. Okay, and you'll see that today. Okay. So a control plane cluster can dual function as a data plane. Okay, so if you don't want to, just waste data, that's fine. You can work with that. So essentially, this is how it kind of looks. You have a control plane, and then you install the multi-cloud cluster on the data plane. Now, obviously, from a Kubernetes perspective, you must be wondering, right? How exactly does that work, right? So how it works is, what you do is you install Cassandra on each of these data plane clusters, okay, and this may happen automatically, let's not worry too much about that. And then what you do is you inject the config of this, or into the data plane, and you inject the config of this into the data plane, and that's kind of how, you can install Cassandra on these different clusters. Essentially, there's a concept of a Cassandra cluster, and you'll see this in action today. You'll see two contexts here, right? One is east and the other is west. So essentially, I'm using a control plane, and I'm using east and west as the data planes, okay? So what it does is it creates a Cassandra data center and then injects the context, which essentially makes it easy to install it. All right. So this is the client config that you essentially inject into the data plane, which makes it easy to make it a multi-cluster. So with that said, let me jump straight into demos. Let me see how I'm doing with respect to time. I have about 10 minutes, which should be more than enough. All right, so let's start with the EKS KubeFed demo. Again, what EKS does is it's pretty cool. I like the project. What happened? Okay, let's not worry about this. All right. So what I'm doing here is it installs a Bastion host. And what the Bastion host does is it installs Kubernetes on two clusters, federated clusters, and sets up all the requisite things, the networking artifacts. So basically, it does the routing, security groups, peering, network peering, all of that. Because one of my requirements was that I want to make it as easy as possible for me to, I know I was going to mess up the first time around, right? I just wanted to kind of do it over and over again. So let me see if I can connect to the Bastion host, and I'll show you what's going on here. Okay, so I'm going to connect to the Bastion host. This is running on EKS, okay? All right, so the first thing I do is do this, and then I set up the paths. All right, and hopefully everybody can see this. And then I'm going to show you what are the contexts. Okay, so you can see there are two of these, right? One of them is fed to 1, and the other one is fed to 2. Okay, and essentially these are the two contexts where I've installed the cluster. Okay, so let me start by showing you the cluster itself. Okay, you can see here, what I'm doing is I'm executing a particular node tool command, which a lot of Cassandra admins use, just to get the status of this, right? So essentially what I'm doing is I'm taking one of the pods here, right? And then what I'm doing is I'm invoking this command called node tool, and I'm providing the username and the password. Not very imaginative here. Definitely don't do this, but I'm doing this for the demo, right? So I think it's pretty cool, right? And you can see here that it's a big cluster, DC1 and DC2. So just to see, let's look at this nodes. Okay, describe nodes. This might be good enough, okay? Actually, let me do this. Let me clear this up and bring it to the top so that you guys can see it. Okay, you can see that it's running in EU Central 1, EU Central 1B, Central 1A, Central 1C. So it's already rack aware. Okay, so if one of these racks fail, no problem. Cassandra keeps ticking because it can actually service it from the other racks and so on. But now, not only that, what I've done is I have made it in such a way that I have spread it across multiple regions. Okay. So now if I do the same thing here, you will see, so this one was Frankfurt, right? I believe this was Frankfurt, and this is Dublin. Does that make sense? So I'm able to connect these two together and make it a Cassandra cluster. I did not do, I told you already, I'm not a networking geek, but EKS KubeFed was really cool. I leveraged the EKS KubeFed project and essentially made this happen, okay? I'm trying to think if there is anything else I need to show here. I showed you the nodes. You can see that it's running. Actually, maybe what I should do is I should bring up the presentation for just a brief second because I want to show you something which is really cool. Right here. Okay, view, slideshow. Okay, and this might give you a little bit more context. So this is the EKS KubeFed, and if you can't see it, don't worry too much about it. I'll explain this. Okay, so this is the Bastion host, 172.20. And then what it did was it created two VPCs in region 2 and region 1, okay? So it was 172.21 on West and 172.22, I believe, on EU Central, right? All of this was automatically created for me, which is really cool, right? And then all that I did was I enabled them manually by inserting the seed from one of these clusters into the other cluster, and then it can start gossiping. But now with Cassandra operator, you don't even have to do that. I don't have to manually install anything. All that I need to do is specify the control plane and then say these are the data planes, and then I'm going to inject the configs and everything works fantastically. All right, so let me see. The proof is going to be in the pudding. Let me see if it works, really. All right, so Cassandra operator, let me go. So what I'm going to show here is, let me go to the notes so that you don't have to. So I installed everything here. Okay, let me do this. I'll show you. Okay. So I have 3 clusters here. Okay, let me. Do you guys want me to increase the font level a little bit? Doesn't look like it's working, but it's fine. All right, I'll walk through this. So you can see here there are 3 clusters, right? AKS, EKS, and GKE, okay? So AKS is the control plane, and then EKS and GKE are the data planes, okay? So what I'm going to do here, again, just go back to the same command, right? Let me go to this EKS cluster, right? And then I'm going to show you that it's running. Basically, I'm trying to figure out what the control plane value of this is. Okay, and you can see here that this is running false because this is one of the data planes, right? So if I go back to my AKS, so if I do this, hopefully this is going to come back as true, right? Okay, so do you see that? It's basically true. And then what I can do is I install something called a Cassandra cluster. Okay, and all that I do here is kind of do this, and I'm gripping the DC. So what I'm doing here is, just trying to find the data centers. And you can see here, it's running on, where am I? Oh, yeah. So the first DC is an EKS, and the second DC is on GKE. You guys see that, So it's kind of cool. Let me go to GKE. Let me do a kube context. And let me go to the GKE cluster. Okay, and what I'm going to do here is look at the nodes, get nodes minus O wide. Okay, and you will see here, you will see the nodes that are running here. 2110, and I think it's opinionated implementation. 10.3 is on GKE. 10.1 is AKS, and 10.2 is the third one. Okay, whatever that is. Okay, so if I, for example, if I go to AKS, okay, and you'll see here, if I do the same thing here, you will see that this is 10.2 2. Okay, and if I go to the last one, which is EKS, you should probably see it as. And all this is done pretty straightforward, and I'll talk about that in a second. And you'll see that this should probably be 10. Oh, what happened? Oh, EKS, that's what I was looking for. So let me go to EKS, and this should be 10.1. Okay, so you see this? All of this is automatically enabled for me using the Terraform scripts that I'm going to show you about. Okay, so now what I do is I go back into my, and get the usernames. Okay, so username and password. I've already done this, so I'm not going to waste your time going through that. So let me run this. And I'm on EKS, so let's see if this works. Okay, so again, what I'm doing here is I'm running the command to see where the cluster is. And you'll see here there are two data centers, EKS and GKE, okay? And both of them are joined as one cluster, okay, which is kind of cool, okay? Because, oh, that's not what I meant. Yeah, so this is what I wanted to run. And all that I'm doing is I'm running the pod, and again, running the same node tool command. You know, a lot of, again, Cassandra admins do this all over, right? And essentially, you have two data centers, EKS and GKE, joined together, okay? So pretty straightforward. Hopefully, that was illustrative of what I was going to show you. And let me round up with some resources. Okay, I finished the demo. What's next? Surprisingly, Cassandra.io has a lot of good documentation. Okay, I mean, that's one of the banes of technology, right? You know, the technology is cool, somehow the documentation sucks, right? But actually, documentation is pretty good. So take a look at this. I myself wrote a how to multi-region with Cassandra and KubeFed, okay? So take a look at this if you're interested. Why did we come up with Cassandra operator? The reason is to make it easy on multi-cloud, multi-region, multi-whatever, right? And that's the reason why we came up with the Cassandra operator. So might help to kind of dig into why, the rationale behind that. If you're interested in Astra, you can sign up. We give $25 credit a month, which actually is good for running production workloads. We run workshops every week. You know, we get a lot of people from Europe, get a lot of people from Asia. All of them are free. You know, feel free to attend any of them, especially if you want to do a little bit more development. You know, it's aimed at really beginning developers, but sometimes we have some advanced topics as well. Datastax.com workshops. In fact, I think this week on Wednesday we have revamped our intro to NoSQL workshop. So if you're interested. By the way, anybody attended our workshops anytime? Never before? One person, okay. What do you think? Yeah, it's really cool because that kind of kept me sane for the last year or so, because even in a virtual scenario, we have literally 600 people participating, and maybe about 200 people are talking and chatting and all that. And that's the only way, like I said, it's kept me sane.
start again meeting people and especially, at this kind of events that you are, meeting a lot of people and seeing a lot of old friends. So thank you. I really appreciate that. Okay. So after this long title of the conference, what I want to do is to explain what NetApp is doing to provide a solution to, give data protection to Kubernetes applications. No? And why NetApp? Because we have been, providing data and persistent data for the last 6 years, in the Kubernetes world since 2016 with our Trident CSI provisioner. Before it was not CSI, before CSI or the Container Storage Interface API existed. So what I really want to tell you is what is Astra and what Astra can do to help you and to make your Kubernetes applications be safer and that you can do things like disaster recovery and this kind of things. Okay, so a very brief marketing introduction in the sense of saying, okay, everybody's starting to use Kubernetes out there, and most workloads are stateful. No? That means that they are using some persistent storage just to make sure if the container dies, everything keeps running. No? So because the data is there. Okay, so the dynamic provisioning that was born in 2016 with Kubernetes version 1.4, when the words storage class appear in the horizon. So it helped to provide automatic provisioning of volumes to Kubernetes applications. So this is more or less has been used for 6 years and is clear, is solved, no problem. So everybody out there, all storage vendors, they have a storage provisioner. After some years, the Kubernetes community provided this container storage interface just to make sure that everybody out there was following the same API to create volumes, destroy volumes, connect volumes, mount the volumes in the pods, in the containers. So this is completely solved, no? And NetApp has been there for these 6 years, providing through Trident, through our provisioner, this solution. No? So no problem to provide persistent storage to Kubernetes application. But what happens if the data inside this persistent volumes is lost, is corrupted, somebody accidentally deleted, okay, these kind of things. So they could happen and you need to solve them, no? Because sometimes the data that is used by the applications is much more important than the Kubernetes cluster. So it's easy to deploy a Kubernetes cluster. You just spin up one Kubernetes cluster in the public cloud in 15 minutes or less. So this is not a problem, but if you are using, applications that use data and this data goes away, you really have a huge problem. No? And also, the other need that is important is this capability to move applications, Kubernetes applications, from one Kubernetes cluster to another Kubernetes cluster. No? So we're starting to need these kind of things more and more, maybe sometimes as part of a CI/CD pipeline or this kind of things, but in general, it's very interesting to have the capability to take the Kubernetes application that is running in production and move it to a pre-production, a testing environment, and just run the latest piece of code in using the data that has been used in production. Okay, so this is more and more interesting. And what we really need is some kind of application-aware data protection solutions, no? That they treat Kubernetes application as an entire unit, no? As a whole. No? So just to make sure that you can protect everything, not only the data that is inside the persistent volume, that is very important and is very valuable, but also all the Kubernetes objects, all the metadata, and here you have all these words that we have been hearing for the last years, no? Stateful set, deployment, secrets, config maps. All these things need to be protected as well as the data that is inside the persistent volumes if we want to provide a real data protection solution. Okay? So NetApp Astra Control is the solution to that from NetApp we try to provide a solution for this, no? Just to make sure that when you are protecting an application in Kubernetes, we are taking care of all the objects, all the metadata that is part of this application, not only the data that is inside the persistent volumes that we can easily make a snapshot, a CSI snapshot, or make a clone. Okay? So with Astra, we provide automation, we provide protection, we provide mobility, we provide governance. And no matter what is your workload in Kubernetes, no matter which is the Kubernetes distribution that you are using, if you are in the public cloud, if you are on-prem, or if you are in the data center, and no matter the backend storage or the persistent storage that you are using. No? It can be in the public cloud, and in the public cloud you are using maybe Azure Disk or Google Persistent Disk. So we want to provide a data protection solution to protect everything there. Okay. So Astra Control Service is part of this suite of Astra Control that is, the special thing about Astra Control Service is that it's a managed service. No? So NetApp provides this service as a fully managed service operated by NetApp, and you just have to consume. No? In the same way, when you are looking for a Kubernetes cluster in the public cloud, and you start one AKS or EKS cluster in AWS, or an AKS cluster in Azure, or a GKE cluster in Google, in the same way you are consuming Kubernetes clusters to run your applications, Astra Control Service provides data protection as a service. So you just register, and then you can start protecting your applications in the public cloud as a managed service. You don't have to install anything in your Kubernetes cluster, so in this sense it's a complete agentless solution. And with that, you just can provide the right credentials to connect to your Kubernetes clusters, and we will start discovering the applications that are running in your Kubernetes cluster, and we will offer data protection to them. Once we have registered your applications, you can do a snapshot, you can do a clone from a snapshot, you can do a backup, you can do a restore, you can provide disaster recovery in general to your applications. Okay? So this is more or less the solution. And I'm going to go straight to the demo, and hope you like it. I'm going to risk a live demo. Okay, so let's see how it works. And if you have any questions, you can interrupt me and ask any question and make this interactive. So let me see if you can see this well. Okay, I have, following with the multi-cloud story that we were hearing in the previous session, I have one Kubernetes cluster in Microsoft Azure that is called CNDM Day, okay, Cloud Native Data Management Day, main. Okay, this is like our main Kubernetes cluster running in Azure, sorry. And we have another cluster created that is called CNDM Day DR, okay, to try to simulate our disaster recovery Kubernetes cluster. No? And this is running in GKE, in Google Cloud. When you use NetApp Astra for the first time, you just have to register in the service, okay? And we provide you with an account, and you can all of you can test this thing because it's completely available for testing. So you can register and you can start playing with the solution, and you have the full feature of the product completely available for you, just limited to 10 managed namespaces, okay? So you can only protect up to 10 namespaces in all your clusters, okay? But you can play by yourself. No? So you register, you can see this dashboard initially, and the most important thing here is in the account, you have to provide the credentials to connect to your projects inside the public cloud. So I have provided, a credential for Microsoft Azure, another credential for Google Platform. These are the service principal. Just the service account just used to connect to your project in the public cloud, so Astra is able to explore which Kubernetes clusters are running inside your project in the public cloud. Okay? Then, when you provide these things, you can start managing Kubernetes clusters. No? And as you can see here, I have I'm already managing this main cluster, okay, that is running in Azure. You can see the version that is running, the 121, and the location of our Kubernetes cluster. No? And I have here this button with actions, so I can stop managing the Kubernetes cluster. Okay. And the other thing we have here is applications, okay, and buckets. Okay. The buckets are, the storage destination for our backups. So we provide snapshots. The snapshots are CSI snapshots, so they are going to be in the same cluster where the application is running. So if you lose completely the Kubernetes cluster, then you have a problem because the snapshot is also gone. No? The persistent volumes and the snapshot they are gone. So you somehow have to make sure and need to protect and need to save outside your Kubernetes cluster all the data and all the metadata. Okay. So the buckets here are for that. We provide object storage to store, all the backups outside the Kubernetes clusters. Okay, and as you can see, I can add more buckets here. So the only thing you have to do is to provide the public cloud where your object storage is, the bucket name, and the credentials. Okay, and that's all. Sorry, because I'm zooming in a lot, just to make sure that everybody can see the screen, from the back of the room. Okay. So normally this has this size. So let me come back to a reasonable size to everybody can see. And the last thing is the application. So as you can see, I have two applications running in my AKS cluster. One is MySQL and the other one is PostgreSQL. This could be the normal screen size for this application to run. Again, let me make sure you all can see this thing. Okay, so and these are the Discover applications running in the cluster, but I have another tab here that you can see Manage. So I'm still not managing any of these applications that are already running in the Kubernetes cluster. So if I want to provide data protection for them, I just have to come back to applications, to the Discover thing, and just click in the action button, Manage. Okay, it's as simple as that. Okay, and as you can see now, this entire namespace, MySQL namespace, is managed, and we can start protecting it. Okay, I'm going to manage as well the PostgreSQL namespace. Okay, and now I can switch to the Manage tab, and you can see that there is a warning sign saying, "Oh, this is not protected. You need to protect these things. Okay, they are important." Blah blah blah. So I can. The first thing I want to show you is what for Astra is a Kubernetes application. No? And you can see here the list of resources that we are protecting. So it's obviously the PVC and what is inside the PVC, the persistent volume claim, but also the config map, the deployment, the replica set, the secrets, even the service account of the namespace. Okay, so you can see all these things are going to be snapshotted, all these things are going to be backup. Just to start protecting, you can see where this thing is running as well in the node. What I can do is to do a snapshot, create on-demand snapshots, so I can do one snapshot wherever I want. So I'm going to create one snapshot. Okay, let me reduce the zoom. Okay, as you can see, the only thing that I have to provide is a name for the snapshot. He's putting a timestamp there, so the timestamp is fine with me. So I'm going to click next, summary of what I'm going to do. Okay, click a snapshot, and that's all, okay? So we are creating a CSI snapshot, but it's not only containing the PVC, it's a snapshot of the config map, the deployment, all the configuration, all the metadata of the application as it is today, okay? As it is now, okay? Then I can also create configuration protection policies. This is a kind of a schedule. Let me see if you can see this better, okay? Where you can see, I can say, okay, I want to protect this application, and I want to make sure that every hour I have a snapshot, and I want to keep the latest 8 snapshots or hourly snapshots, okay? And I want to apply for a daily data protection policy, and I want to do the backup at 3 a.m. UTC times, LU, and I want to keep the latest 7 snapshots, and I want to keep the latest 7 backups, okay? So this is like the frequency and the retention, and you can establish all this. You can change the bucket for the daily backups, put a new bucket for weekly backups, okay? So here you have your policy. For example, I want to do the weekly backup on Sundays, okay? And once you are good with the policy, you just click next. There is a summary of the policy, and Astra will take care and will start protecting with snapshots and with external backups the Kubernetes application. So as you can see, it's quite easy to use. You can also do backups on demand, okay? So there is the snapshot tab and the backup tab. So we can just create a backup. I can do the backup from the existing snapshot. If you don't choose this, he's going to create a new CSI snapshot, and he's going to use the snapshot to mount it, read the contents on the PVC, and back them up in the object storage in the bucket. Okay. I'm going to use the snapshot that we just created. Okay. And that's all, okay? Giving a name, selecting the snapshot or not selecting the snapshot, do a backup now, and he will do the backup, okay? So it's just like that. I will have a progress bar to see the progress of my backup. In the meantime, I would like to show you how to add a new cluster. So I'm only managing my main cluster. Now I want to provide disaster recovery to my environment. I want to add the disaster recovery cluster, and instead of using Azure to be in a different region, for example, that I can do that, I'm going to try to do a cross public cloud or cross hyperscaler disaster recovery. So I'm going to add the GKE cluster that I just showed you. Okay, let's click next. As you can see here, he's scanning inside with the credentials of my account. He's scanning inside the project of my Google Cloud Platform account, and he's discovering a GKE cluster, okay? So he's offering me to protect it. As you can see, this GKE cluster is in the Europe Southwest region, okay? And you can see a warning sign here saying, is eligible? Yes, it's eligible, because this is a warning, it's not an error. This is only saying, okay, we would like for you to use always NetApp storage in the public cloud. So as you know, we have cloud volume services in Google Platform. We have Azure NetApp files in Azure. We have FSX for NetApp on tap in AWS. So we have our offering of storage in the 3 public clouds, no? And ideally, we would like you to use our storage, but even if you are using the native storage, we can protect the Kubernetes cluster. So I'm going to click next. He's going to scan now the Kubernetes cluster. He's going to see which are the storage classes that are already there, okay? If the NetApp storage would be available for this cluster, he will automatically install Trident and configure Trident to make sure that you can use NetApp storage as a persistent storage in this Kubernetes cluster. It's not the case. I don't have NetApp storage connected to this cluster. I'm going to choose the default storage class that I want to make sure is always used, because I need a container storage interface, a CSI compatible storage class to do the snapshots, okay? So this is the reason of choosing, and that's all, okay? So it's next, and I'm going to add a GK cluster to my Astra Control, okay, service. As you can see, this is a slightly different Kubernetes version, okay? And one is running in France Central, the other one is running in southwest of Europe, and one is a different public cloud provider or hyperscaler, okay? I'm going also to launch a snapshot of the PostgreSQL. One of the cool things of Astra Control Service that is all the time trying to discover new applications inside the Kubernetes clusters that you are managing, okay? So if I deploy now, for example, a MongoDB database using, for example, this Helm chart. I'm sure that you cannot read what I'm showing you, okay? But let's try to see it here. As you can see, this is in the behind the scenes. This is our cluster, okay? I'm going to deploy a MongoDB database and Astra Control Service. When the deployment of MongoDB finishes, it will be able to discover, and I will be able to manage this new MongoDB application, okay? Okay, so what I'm going to do now, because I have two clusters, and for example, the MySQL application is already protected with a backup and a snapshot, I'm going to simulate a disaster recovery. No? So I'm going to clone or restore my MySQL database from the AKS Kubernetes cluster to the GK Kubernetes cluster. So I just have to click in the action button, click restore, okay? And in the restore details, you can see that I can choose between the current cluster, so I could clone my application to a different namespace in the source cluster, in the current cluster, or I can choose my disaster recovery cluster that is in Google, it's in GKE. Okay? I'm going to do that. I'm going to put the name of the namespace I want to create to recover my MySQL application. I'm going to choose the MySQL name, okay? And I just need to select from which snapshot or from which backup I want to restore my MySQL application. So because I just finished doing this backup, I'm going to choose the latest one, the only one that I have available here. Click next, summary of what he's going to do. I'm going to restore all these things, not only the data, all the deployment, the config map, the secrets, okay, just to make sure that everything is going to work, okay. I'm going to click restore, and in the meantime, I wanted to also to show to you the what more things we can do with Astra Control Service. For example, we have execution hooks. So Astra Control Service is capable of detecting what is running inside the pod, and he has a list of applications that we are able to detect automatically. So he has automatically detected inside this namespace a PostgreSQL is running, and he has automatically applied pre-snapshot and post-snapshot scripts just to make sure that when we take a snapshot and use this snapshot to do backup, is completely consistent. Okay, so that is the idea. You can also add new hooks to specify the actions you want to take in the pre-snapshot and post-snapshot activities. Okay. So let's see what is happening behind the scenes, okay? So I'm going to, this is our main cluster, as you can see, I have, if this connects, three namespaces, the MongoDB that was just created, the MySQL and the PostgreSQL. I'm going to connect to my DR cluster, so let me use the screen below, and I'm going to finish with this. I'm going to use now the GKE context for my kubectl. So let's see what is happening in my disaster recovery cluster. As you can see, a new namespace called MySQL was created 100 seconds ago. So let's see if I'm able to see what is happening in the SQL namespace. As you can see, he has already provided the persistent volume claim, and my pod is running. Okay, so the disaster recovery is completed. No? And as you can see, especially the simplicity of using this tool. So my cat can do disaster recovery of Kubernetes with this thing. Okay, so and that's all from my side. I don't know if you have any question. As you can see, the MongoDB that we deployed earlier now appears here in the discovery things, and we can start managing and protecting the MongoDB database. Okay, and that's all from my side. Any question? Anybody? Yes?
When you take a snapshot on the main cluster, is that the snapshot class provided by NetApp or?
No, the snapshot class is provided by the vendor of the storage class that has is providing the persistent volume claim. In this case, we are using the premium read-write-once storage class from Azure Disk, and the snapshot class is the one provided for Azure Disk, the CSI snapshot class of Azure Disk. In fact, you can see it here if you change again the context. This is the native data management main. So now we can see get volume snapshot class is this, no? If I remember well. You can see the Azure disk, the Azure file. These are the ones. And I can see the snapshot that Astra is created because they are CSI snapshot. No? So I can get the volume snapshot contents. I believe this is namespaced. So you can see here the snapshots, okay? So everything is CSI compliance. I don't know if that was your question or...
No, I was just wondering who owns the snapshot, basically.
So if it's NetApp storage, we are providing all the CSI driver with Trident, and Trident has its own CSI volume snapshot class and everything, okay?
And all the backups are incremental or are
Sorry?
Full? All the backups, are they incremental or full?
They are full. Right now, they are full. Okay. So thank you very much. Any other question?
All right, good. So big applause here for a great presentation and a demo. We always love demos. Next up is the most exciting part of this CNDM Day panel conversation. Always great interaction here. So the panel is going to be led by Camberley Bates of Evaluator Group, and I would like to ask our panelists also to come to the stage. We have Enrico Bartz, Head of Competence Center Container and Multi-Cloud Management, SVA. We've got Aditya, Dani, Software Architect, Portworx by Pure Storage. Tom Enfield, VP of Engineering, Cassandra by Veeam, and Satya Sankaran, who is COO at Catalogic. 4 people, that's awesome. Yeah, we will. You can already take this one. Camberley.
Hi, folks. Good afternoon. Good morning to the people in the U.S. if you're actually looking at this. We've got one mic here for everybody. Okay. This is going to be an interesting panel because we've had, actually this is an extra seat. We have multiple extra seats because we've had people falling by the wayside because of COVID. So don't laugh. We all could be one of those too. That's what I'm afraid of. Okay, should we be wearing masks? There we go. Okay. For those of you who don't know, Evaluator Group is an analyst firm. We're based out of Colorado, in Boulder, Colorado, actually. And we specialize in information management, focusing primarily on the infrastructure. Topic today is going to be Kubernetes, cyber attacks, and planning for the inevitable, which I think we have all felt the experience of this. I know for ourselves, we have been called in with our IT end users on numerous occasions over the last couple of years to do audits. We focus on the data protection and recovery side of that audit as opposed to the web services side of it, which is not an entirely different game, especially as those who was all involved with data protection. Congratulations now for being one of the more important people in your company because you are the last state of defense and the CISO is now experiencing that and understanding that. So that's all good news. So I'm going to start out before I introduce the gentleman on the stage here with a couple opening comments. I'm going to read a few stats off. And pardon me as I use the old-fashioned paper because it's more effective for me than the computer. And this is coming from CNCF, Carbon Black, Veritas, in our research. Can't see. Could you switch on the light again, please? Because otherwise, oh yeah, there we go. 66% of the enterprises have deployed containers, with a third being mission control applications. That is probably a very high number because it came from CNCF, maybe not quite the same in the reality world. But 46% of the enterprises see transactional workloads as the future and top priority with containers. 2/3 of those with mission critical apps have no data protection. Is that a surprise? I don't think so. SecOps reports 94% of these environments, that is container environments, have been attacked. And DevOps reports 41% of the environments have been attacked. A little bit of a difference of opinion, I would say. So the issues that we continue to see raised, and that's what we're going to talk about today, one is open source and trust issues. Big stuff. Especially if you're in the federal government, I don't know if you've seen the executive orders on that, where they're implementing, zero trust. Yep, thank you. With containers, in addition to supply chain issues, the perimeter and the network, so now we're looking inside of the world, the attack surface has expanded extremely to a very large environment now, and that gives people pause. Best practices is to move into a place of never trust, always verify, except for that's not exactly easy, is it? So there we are, big attack surfaces, and probably because the most likely suspect is the user clicking on something that's going to let something in that's internally already into the system. And lastly, data protection changes. Still many believe that they don't have to do data protection. I will, if I can, I'll pull out a quote here and quote that a little bit later about some of the things that we're seeing. So, with no further ado, I'm going to ask each of these gentlemen to introduce themselves briefly. Part of it, and I also want to give a shout out to a couple people. Xing Yang was supposed to be here. She's down with COVID. Guillaume from Red Hat was supposed to be here. He is in his hotel with COVID. Also, Joey Lee, who was supposed to be here from Portworx, he is down with COVID. So I want to say thank you, all of you guys that are still healthy and have showed up. So I'll pass it on to you.
Is this working?
Yeah.
Okay. My name is Aditya Dani. I'm a software architect at Portworx. I'm glad to be here on the panel.
Great.
Hey everyone, I'm Satya Sankaran, founder and GM of Cloud Casa. We deliver data protection as a service for Kubernetes.
Hi, my name is Enrico. I'm working at SVA. We're a systems integrator in Germany, and my role is that I'm leading everything that's responsible for Kubernetes platforms or container platforms and cloud native or multi-cloud management. So thanks for having me.
My name is Tom Manville. I'm VP of Engineering at Cassandra by Veeam. We do data protection for Kubernetes specifically, and I think your intro is great. Thank you. That was a good, I think, overview of everything. So I look forward to this talk.
Great. So my first question, and we're still going to be a little high level right now, because we've already talked about it in the presentations, but we're going to do it one more time and get it from these guys. And that is, what is so different about data protection and security when we start talking about containers? Who wants to take it? Go for it.
I think change is the only constant thing in the cloud native world. And I think as DevOps, as admins, you need to consider that in every aspect of data protection and security. So I feel that agility is the key. So you need to anticipate things that might come in the future and keep your data protection and security techniques in place instead of having it handling them when things have gone wrong. So that's what I think.
Can I add to that?
Yes.
Yeah. I think in the cloud native space, we see many different trends. So one of the trends we see is a focus on open source. And so all of a sudden you have an explosion of dependencies in your builds, and it increases your attack area pretty significantly. We also see hooks into different layers of abstraction. So one great thing about the cloud native space is that there are many different layers of abstraction that you can consume and build upon. And that just, of course, introduces more vectors for attacks, as well as maybe some lack of understanding potentially if you don't know what's under the covers of some abstractions. Also in general, we actually in the data protection space have historically really focused on things like operational errors and maybe hardware failures and that type of thing. But I think there's been a huge rise in ransomware. So security is definitely a big focus now. And I think it's actually more of even just a general historical trend and not just something cloud native specific.
Absolutely. Enrico.
Yeah, I think what's kind of different here is if we abstract all the different types of things that we do in IT, so storage, networking, security, all that kind of things, and abstract this with Kubernetes. That means if some developer that has his .cube folder in his home directory sitting there with the kubeconfig files, it's not just like leaking an SSH key and getting access to a couple of servers. It's getting access to your whole infrastructure and being capable of doing things in there. So I think if you leak those secrets, it's pretty different from what happened if you I don't know, lose a password or something like this before.
Absolutely.
Yeah, I mean, I think it's, with Kubernetes, there's just so many moving parts. I mean, I know most of us here know how to drive a car. Suddenly, if you told someone to go drive a plane, yes, a lot of the concepts are the same, but how many of us know how to drive a plane, right? So there's just so many moving parts, so many dials, so many things to worry about. I think all of that creates the attack surface to be a lot higher because again, you can know and fully understand some pieces well and protect that, but there are so many pieces you don't understand. Nobody is an expert at everything in Kubernetes, and I think with that knowledge gap as well, I think security becomes a big issue for Kubernetes users.
Right. And my husband was talking about he does pretty big product development in these type of environments. And one of the things he mentioned to me the other day, that somebody was sharing secrets on their Slack. That's scary, guys. But that's the kind of, we don't have the disciplines we typically have in other environments, that they're sharing how they're connecting all of these containers. Enrico, it's not that funny, really, it isn't.
I mean, I'm just thinking about if I ask people to send me an SSH key, how many times did it happen that they sent me the private key? But it's supposed to be private, so, but yeah, that kind of thing happens, and if your Kubernetes secret is like just a YAML file, how do I differentiate that this is like the secret kind of thing? And yeah, people are sending that over Slack or posting it on GitHub and stuff like that, so that happens.
Yeah, and A lot of people check in their passwords in
Exactly,
source codes. Right, you go through source code, you search for password, you're sure to find some hard-coded password for something in there.
And there was this, I was saying, I won't mention the vendor that was demoing this, but they were demoing this environment that was demonstrating what things were, and how to identify risk and that kind of thing. And it was saying, on there it said, it talked about the capability, and then it said, no fix. You know, there is an exposure here. It's a known exposure. There is no fix. So what they're talking about is then we take, as managers, you take a look and saying, okay, what's high risk, what's not risk, and what can we deploy? Because there is no known fix to this gap that's there. That, to me, gives me pause. Lots of pause. Okay.
And it should. I mean, a lot of CISOs go through audits and they look through everything. And you know, at the end of this, there is a risk acceptance thing. And if that's 4 pages long, you know, we have a problem, right? And I think that's kind of the problems we see with Kubernetes as well, because there are, again, so many parts to this. And there are so many dependencies that are outside of your control, a lot of open source dependencies. We see very popular products, including one I think a lot of us are exposed to. Valero has underlying binaries that have defects that they have no possibility to fix because they're using someone else's code. They can't fix it. And all of that kind of plays a role into what we need to watch out for and where we need to build our observability and traceability into the system as well.
Okay, have we hammered in enough that there's a lot of exposures? Can we move on to the next discussion? Okay, there we go. Okay, so the next one that I have here, one of the challenges is the rate of change in the new code. Now I know CNCF, they've slowed down to where it's 3 times a year, but I work with large IT enterprises, and they've been used to maybe 2 times a year patching, if best, if you want to look at that. So now we're into that stage of the environment that's changing very much. How do we, where do they look for help in this situation? How do they grapple? How does IT enterprises, not the startup, but IT enterprises deal with this kind of rate of change? What's going to change? What's going to simplify this?
Basically, automation. I mean, if we want to go with Kubernetes, that means that we want to scale. And if we look at those clusters and then patch them by hand, that wouldn't make much sense to me. So if we go like full enterprise, if we go like full production, we should have some hardening supplied already, and then have some automation which regularly checks and updates all the involved parts in our clusters. That's something that we need to do. If we don't, yeah, that's kind of a bad thing. And if we scale up to, I don't know, a couple hundred of clusters with a couple hundred of nodes each, you know, that is something that you won't do manually, I believe.
So Tom, you're part of CNCF. You do a lot of work with the working group. What is CNCF doing here?
Yeah, so there's definitely a lot of work across the board. There's some really good projects that help you scan and understand your vulnerabilities. You know, open source projects, big companies as well. I think for some of the same reasons that there are issues with that these issues are being exposed in the space, there's also benefits, right? I think there's a really big community who is constantly understanding and trying to scan for these vulnerabilities. Because the truth is, no matter what you do, you would actually have vulnerabilities. You'd have to do upgrades more than 2, 3 times a year, essentially, right? So even Kubernetes itself has security fixes that go out on all the major releases. And I think I would emphasize certainly the only way you can get to a secure point is by automating everything, having automatic checks that are continually scanning. I would say even for our infrastructure, we have continuous scans, and there's always issues that come up. And you know, the scary thing is, I think for some there are no fixes, but for most, usually the fixes come out pretty quickly, right? It's the community acts very quickly to patch the most critical issues.
So yeah, Aditya, could you talk about how you guys prioritize your fixes?
Yeah, I think periodic scans is very crucial, and you need to, it's not like every time there's going to be a release, you are going to then run the periodic scan. It's like every day there should be periodic scans happening, and then based on the severity, the CVSS score, you decide whether you have to fix this or are you dependent on some other open source library to fix it. But I think the key thing here is at any point of time, you should be able to release your product or whether it's an open source container or whether it's something that you're using, and you should be able to release it fast enough so that if there is any severity that you need to fix, that goes out as soon as possible. I think that's the key. You cannot be slow in getting things out and be vulnerable.
So, okay, I'll ask this question. Is that realistic? Maintenance is super underappreciated, right? We don't put the guys that do maintenance up at the top of the list. They typically don't get the big awards in the companies. They should. At least the guys that keep my house going, they're important to me. Is that realistic? Enrico, is that realistic to constantly do that patching and really be on top of it, given the skill bases that we don't have?
I mean, we kind of have to, right? And we have to do our best to achieve this.
I have to lose 10 pounds.
Sure, you do. I mean,
is it realistic?
The thing is, in the past, right? The question was the same. Whenever someone comes in and says, where are we affected with this certain CVE? Then you have to have a tool that lets you get this report to maybe identify the systems that you need to patch. And when you're running Kubernetes and scaling up the workloads that you have there, you need to have something that answers this question. If not, then you will have a lot of work. Whenever things like the CVEs that came out recently, I mean, what was it? Guys, help me. It was like
4J?
Yeah, Log4j.
Say that again.
Log4j.
So that came out, and the immediate question is, where are we affected? And next question is, at the systems which are affected by that CVE, has it been used already? And those are the questions that come up. And if you are not prepared for this technically, that means a lot of trouble and a lot of work, manual work, if you don't have any tooling for this. So and this is kind of a normal question, I believe.
Yeah, but I was just going to say, if we look at it as an event, yeah, you can't do this every day, every night, right? That's just not possible. But at the end of the day, software release is a life cycle, and you're saying that people today are comfortable doing that every 6 months. But if we make that a process, if we make that a culture, if we make that a constant state that we're going towards, I think there is, and a lot of organizations have already done it, where they release code a lot faster than once in 6 months. Mm-hmm. So it's certainly a goal that is achievable, and I think this conference is a congregation of a lot of people that are either in that pursuit to achieve that or already have achieved that, right? So it's certainly doable. We just need to build the right ecosystem and the tooling around this, and I think Kubernetes as a community is certainly getting there. We're getting there faster than most other ecosystems out there.
Yeah, I'd say shifting left is a key paradigm in the cloud native space, right? Being able to release as early as possible, get your testing up front, doing the scans early, so that you can fix things as early as they come up.
I think part of the reason is we have an understanding that data has gravity, right? Okay, so let me go on to the next one. Second is, after going into the next one, is protection side. What is so different about specifically data protection when it comes to containers and Kubernetes in those environments? Jeff?
I think what Kubernetes and containers have provided is this multi-tenancy, right? You can have different personas use your Kubernetes cluster, and I think the data protection tools that are out there need to adhere to that multi-tenancy. So you cannot have the traditional way of doing your backups and restores anymore. If you want to do it in Kubernetes, you need to be multi-tenant aware. And I think it has to be done at a granularity like a namespace, so that every user of your Kubernetes cluster is going to probably have different requirements for protecting their data, and you should be able to do that at such granularity. And I think that's what needs to change in every data protection tool.
I'm going to add to this question data protection and recovery. So what's different about both of those? They're not the same. Go ahead, Tom.
Yeah, so I think there's many things that are different in this space, but there's maybe two that I want to highlight. So the first one is you really have to understand the life cycle of an application. in this ecosystem, things are very dynamic, things move around very quickly, and really being able to handle the life cycle of the application and incorporate that into your backup and recovery process is very important because things have changed pretty significantly, right? For legacy applications, maybe the life cycle of an app is it spins up once and then 5 years later it's still around. That's not true in this space. And so you have to understand that when you do restores and when you do backups, things are very dynamic. And the second one I think is around this kind of layer of different abstractions, right? Your data may not be co-located with your application, and so you really have to understand kind of the different domains of where your application is, where your data is, and then of course if there's some kind of disaster or you want to do some testing of migrations of your applications, you have to understand these different domains and make sure that your backup and recovery system will handle those different domains.
Yeah, I think two key elements is ephemerence and elasticity. I think those are the two key pieces of Kubernetes, right? One, ephemerence comes and goes all the time. You can't have a strategy that says, oh, you have to install an agent on each and try to protect them. I think that strategy is just not going to work in the world of Kubernetes. And elasticity, we know a lot of backup applications, Camberley. I know you've covered a whole bunch of them. Going through a sizing exercise, building a blueprint, building an appliance, getting an 80 terabyte box that you keep growing up and up. I mean, that's just not the world that Kubernetes operates in. You start very small, you go very high. We work with a customer who's a theme park company, right? During the summer, they have 22,000 employees. During the winter, they have 1,000 employees. How does this company operate? Every single day, they have a changed face and name for the company. I mean, a data set for the company. And I think that's something that the solutions have to adopt. So you don't get to pre-size and pre-build your applications. You have to be able to adapt it. And for that, you have to be, I think, cloud native to work with Kubernetes.
Enrico, how about the areas that you guys done the implementations?
I mean, what's a bit different there is we're switching from Kubernetes to have like a self-service for all the infrastructure that we have there. And before, maybe we had a backup team that cared about the standards and the things that were on there. And the initiatives that start with containers are mostly starting with things that don't require any persistence. But that changes over time. And in the beginning, I see companies thinking about we don't need backup, we don't do a restore, we do a rebuild. And that is maybe a good idea in the beginning, but when things change, you have to rethink what you're doing there and what you're using. And it's just a matter of time until someone, I don't know, deploys a Postgres or the Cassandra operator that we saw today, tries it out, uses it in production, and no one just notices it that this happened, and no one takes care about the standard backup thingy. I was thinking about we saw Astra like a couple of minutes ago, and I was thinking, where's like the default backup policy that I could apply for everything that comes new, where I would say, okay, at least I have a daily snapshot or something that gets applied to everything that's new, to even if someone forgets it, that I have some kind of those standards. And I think the tools that we are building and that get leveraged are or have to adopt to those standards that we had before in IT that solved those problems at least a little bit, or at least keep a base layer that keeps your data safe.
So I want to, and you kind of a great segue into the next question I want to bring up, which is DevOps. What is their responsibility here? I mean, it used to be there's a wall between IT infrastructure, and as you mentioned, we used to have this we still do, but data protection people that can be kind of keep in the background. Now we're bringing them up forward. Thank you very much. But DevOps is now involved with this because they're deploying constantly. Where does that play? I mean, what's the role of DevOps and IT working together here? Go for it, Tom. You got it.
I think what's become clear is that security is everyone's responsibility, no matter what your role is, even if you're just application developers all the way down to DevOps and
okay, everybody is responsible for security. When's the last time you guys all changed your password?
IT should enforce password changes, but that's maybe another story.
IT should. You really want them to force you to change passwords?
I think big companies do enforce that, and it comes from a good place, right? And so you should be using password managers to change it, but that's maybe another story. I actually have a funny kind of story here. So one of our team members was preparing a demo to present, I think at one of the AWS conferences, and so they deployed, they followed some docs they found online, they deployed MongoDB in AWS, and within 3 hours, it had a ransomware attack. So it was just fake data, so it didn't matter. But I think it's very, very easy for anyone to deploy an application that is not secure, because by default, right, you open up all your ports, right, you make it, very attackable. Essentially, you have a big surface area. So I think having a little bit of understanding and trying to figure out exactly what you can do to deploy secure applications is important for everyone across the board. In this case, obviously, it made a great demo because he was able to show a real ransomware attacker, and I think he hid the key, he blurred out the keys during the presentation, but so no one hopefully sent their Bitcoin to this address. But it was definitely somewhat of a wake-up call for some people on the team, right? It's so easy to go and be attacked in this manner.
Yeah, I would say that DevOps is just focused on delivering something quickly, so a lot of automation focus. But it is so optimized for speed at this point that I think we don't have a lot of stop signs. Everybody drives like they're on a Formula One track, so it's all about speed and no rules, no nothing. And I think that's why there is this new culture of DevSecOps is coming in, which is really just DevOps done right? So it's like you integrate security at every stage of that life cycle, whether it's in vulnerability assessment, whether it's in static software composition analysis, or whether it's at the end of this, you've deployed your application in the cloud and you want to scan for misconfigurations. Over 70% of ransomware attacks and malware attacks in general come because something is misconfigured. And this is, again, going back to so many moving parts, easy to misconfigure something. And 70% of their attacks are coming from misconfiguration. Today, people think, hey, it's a shared responsibility, 50-50. I've got some problems and the cloud provider has got some problems. And there are people saying by 2025, 99% of those problems are going to be pointed at the customer. Because guess what? The cloud providers have the resources to tighten up what they're trying to do. It's the customers that don't end up with the same thing. So what is today's shared responsibility? Just be prepared for that to become a shifting responsibility to you down the road.
In preparation for this, one of the conversations I had was with the Red Hat gentleman, and we had a long discussion about the DevOps and getting them to adopt some of these processes and embracing them. And the only way that he saw sight into this, and he's coming from also the IT end user side, he worked for a big university, et cetera, was for the policies to be easily checked out, checked in, executed, and adopted. And even then, if you have a bronze, silver, gold policy, depending upon what you're talking about, whether it's security or whether it's the data protection or whatever, that's not necessarily as easy. So we're really talking about a fundamental cultural change, not just within IT ops having to understand developers, but developers having to understand IT ops. So I'm going to pass that over for any commentary.
I would say the good things that companies can do is leveraging communities of practice. If the first thing that people do is disabling SE Linux because of things don't work, and then they basically break everything that could prevent some leakage or some code that shouldn't be there from running. You shouldn't make rules that block you from working, and you should make it accessible, and you should also embrace those standards in communities and share standards across the company that others could adopt. I mean, the shared responsibility with DevOps doesn't mean that everyone has to do everything. It's the infrastructure that lets everyone do anything. But not everyone is an expert in anything. So build some good rules and leverage them, and build communities that share those standards across your company. And when you do it the right way and review them, and also learn from each other. I think that's a good starting point. And yeah, don't disable like the default security things at the first day. Just kind of try to understand them and then adopt some changes to them, but not like totally disabling.
I would just like to add one thing in all of this. The DevOps community has to realize that it's not like a set it and forget it kind of thing. It is a continuous effort that you need to put in and to make sure that your clusters and your infrastructure is secure and protected.
I think somebody was talking about hero boards, it's amazing what happens when you put the board up and all of a sudden there's red all over the place and things get fixed that day, it all goes green by the next day, that kind of thing. Although that may not help with relationship building on the two sides, so that's another way. I have one more question, but before we go there, I'm going to see if there's any questions out there that anybody wants to tee up. Okay, don't see that. I'm not sure if there's anything online. So, great. Okay, so I'm going to go to the next question, which is really kind of talking about a bit about attack surface. And we did touch on, managing multi-cluster environments. We're seeing two strategies going out there. Those companies that want to build one big, huge, massive cluster for management purposes, et cetera. And others that want individual clusters lined up with each BU or development environment that's setting out there. Which, pros and cons of both sides, especially as it pertains to security and data protection. Enrico, you want to go first, or am I teeing you up too fast?
I'm a big fan of having multiple clusters. That makes the updating process even easier. I don't want to update my production environment first. I want to have separate clusters in different stages, and maybe also separate the different workloads inside of there. So I'm working a lot with also governmental organizations, and they have this requirements that there have to be different network areas for services that host data, and others which are in a DMZ to maybe have some exposed front ends and back ends. But all those could be in different clusters and have them orchestrated kind of differently. Because if you then leak some of your secrets, that doesn't affect the whole application. Or if you are using directly the Kubernetes API from your workloads, which happens if you use operators, those things can do things in your cluster if you are capable of attacking it. So having that spread across different APIs that you have to authenticate against is, I think, a good first way of at least blocking it from spreading into your whole infrastructure.
I would say, I think managing a large cluster or just a Kubernetes cluster is just hard. So you cannot have a 1,000-node cluster and expect it to be managed very easily. You'll need a team of 10 people to manage such a huge production cluster. Like we have a customer, when they were trying to they have a 1,000-node cluster and they were trying to do an upgrade on Kubernetes patching, and it took them about 3 months to complete that. It's a bit like, it was just a Kubernetes distribution update. So it's utterly difficult to do that. So it does make sense to have multiple clusters and for different use cases, even if it's like a single team managing it. And I think, and even the community is going towards it, right? Building tools, multi-cluster tools, and with KubeFed that we saw in the today's session. So I think that should be the way everyone should try to manage their clusters.
I would say for better or for worse, Kubernetes cluster is one type of failure domain. So a failure domain in terms of just disasters, but also for security. There are many things you can't do with a single big cluster in terms of isolating privileges, right? There is multi-tenancy in Kubernetes, but it doesn't give you all the permissions you need. For example, there are global resources that are common across the whole cluster that you can't partition the permissions for. And so I think in some cases you have to have multiple clusters. However, managing those multiple clusters is definitely a challenge, right? I mean, I think the ultimate goal of these projects is so that you can you'll be able to deploy and configure all these clusters in a very automated way. But it still is definitely very challenging, right? I think people, have had their clusters up for a very long time. It can still be very challenging to manage all of those.
Yeah, I mean, I think it's a reflection of current state in Kubernetes that everybody is saying, hey, we have to have multiple clusters, right? That's just that's just a reflection of where we are.
But we're still seeing the others.
Multi-tenancy is just not built into Kubernetes in terms of true multi-tenancy, because the control plane is still shared across these worker nodes. So I think we as developers are going towards using multiple clusters because it's clear separation. I can manage it, I can maintain it going forward. But we're also hearing the other side where enterprises are saying, hey, I want my dev teams and QA teams and production teams to all share one big cluster and kind of work in a single cluster multi-tenant model. And there are solutions that are kind of coming up with soft multi-tenancy capabilities. I think Capsule is one of those tools. And so, again, from data protection and security perspective, I think it's about enabling RBAC capabilities, right? So Kubernetes is doing a good job at RBAC these days, and us applications should certainly kind of look at that as a model and say, we want to be able to create compartmentalization of resources and say, these namespaces, this particular user can provide backup and self-service recovery on, and there is these namespaces I don't want them to give that access to. So I think multi-cluster is certainly the default and standard today, but enterprises are looking for that single tenant solution as well. I think there is a lot of effort going on in the community to enable that use case.
I totally agree. From a user perspective, having one cluster is much easier because you don't have to manage so many individual things. And I think if the community builds better tooling around RBAC and things, then you'll be able to have that single large cluster. Until we get there, though, I think you'll be stuck with multi-cluster for security and other reasons. Okay, great. Are we done, or we got 5 more minutes? I've got more time. Awesome. Great. Okay, so I got another question. Huh? Yeah. We're going to keep on rolling here. So my next question. Traditional backup says 3, 2, 1, and now 1 for the air gap, right? Is this changing at all for containers in Kubernetes?
So I think
I would say it already has changed to some extent. I think Cass's parent.
We got a difference of opinion here. I love it.
Yeah.
Go ahead.
That's great. No, I'd love to hear your point as well. So what is 3, 2, 1? So 3, 2, 1 is the goal. You should come up with a backup plan that has 3 copies of your data, 2 of which are on different types of media, 1 of which is offsite, and now the extra 1 that
is air gap.
Is air gap mode, and then I think the other thing that our parent company Veeam prescribes is also to have 0 errors during your recovery process, right? I think what they were seeing was a lot of people were not actually doing test recoveries. So test recoveries are very important, but even the last one that you pointed out on air gap mode is especially important. If you have data protection solutions that protect against ransomware through immutable backups, I would also kind of classify that in that final one of the 3, 2, 1, 1, 0.
Except somebody
We're
kind
running
of
out of numbers, by the way.
Yeah. So 3, 2, 1, 1, 1, 0, I guess.
Minus 2.
Yeah.
Somebody I recently interviewed about that using, and I thought about it for a while and I said, okay, that's kind of weird, but using the air gap, using the cloud, using the S3, using the object logical air gap, I can get rid of that by killing your account.
And in fact,
anyway, that's a diversion, I understand, but it just kind of like another one that scares you. So anyway, I'll turn it back. 3, 2, 1, 1, and today's practices with Kubernetes.
Yeah, I do agree. Like even in the Kubernetes world, you need the 3, 2, 1, 1 strategy, and I think the attack points or the data loss scenarios are exactly the same or even more. So you cannot run away from this strategy. So you need to use it even for Kubernetes workloads.
3, 2, 1, 1 has nothing to do with Kubernetes. I think it's just good practice. Wherever your workload is, follow that is kind of what I would say.
I think the intent of 3, 2, 1, 1 is that you want to map your failure domains to your disaster recovery plans. So if you're going to lose some specific domain, then you want to be able to fail over to a different domain. And so that's why it's talking about having backups offsite, backups in different types of media. So you can imagine if one cluster gets compromised, you want to make sure that you're able to still recover your data in another cluster, another availability zone, another data center. And so I think the intent of that is a way to simplify this idea that you need to make sure your disaster recovery plan accounts for these different failure domains.
Yeah, I mean, I totally agree with this. The rules that are made are not just made of some techniques or technologies. But what I would say is, you also mentioned that we should do recovery testing, and we should have backup plans and failover plans, and we should test them regularly with every new tool that we bring in, because I mean, in the fast world of DevOps, you will have some shortcomings, at least I have them, where you are at the whiteboard and you think about things and then you install it and think, yeah, I've thought about everything and it would work probably somehow, I guess. And then you're at the point where you're really like trying it out and shutting down your masters and see, oh, I totally forgot that I need to replicate data there somehow to get it back to work, or maybe I'm not able to restore because in another data center I don't have the same ingress or whatever type of infrastructure available. So it's not just thinking about it. You have to test it, and you have to test it regularly. And yeah, you should make sure maybe that also the recovery process gets part of your everyday task. Could be an automated backup and recovery of your data from production environments and then into test environments, which uses the same tools in which you do backup and recovery. So you just integrate those restore tests into regular tasks that help you to get your infrastructure up to date or something.
So that kind of gets into this next piece of recovery and being able to recover in a containerized environment in a consistent fashion. So it took us years to get consistency in the other environment, where application consistent was, an eventual thing. Oracle kind of, I think, led the way on that, and then everybody else kind of fell aligned with it versus crash consistent. In this situation, we've got multiple elements that we have to protect and we have to recover. So does recovery testing change at all in this process?
I mean, the need for recovery testing doesn't change, but the amount of effort involved in recovery testing has changed. I can give you a simple example. When we first started building a backup and recovery solution for Kubernetes, first thing we looked at is how easy it is to recover. And you had to go back to 25 years ago when we were doing restore of a server by spinning up a server, getting the agent installed, and then you start the server. So you actually need a function.
Are you doing that with tape 20 years ago still?
Yeah. I mean, there are still people doing tape today. But anyway, I think the recovery process used to be that you had to actually get a functional environment up and running before the first byte can move. And we looked at that and we said, oh, this is like so 20 years ago when it comes to recovery. So I think there are ways you can build. I mean, what we've done is really creating a composable recovery, which is that we don't want to just have you have a cluster up and running and sitting there for recovery testing. We want to be able to bring up that cluster through code and then install everything and then do the restores automatically. You have ways to connect into cloud and say spin up an EKS cluster so easily. You have ways to connect to Azure and say spin up an AKS cluster easily. So I think from our standpoint, we just need to make recovery testing a lot easier. Today, that's unfortunately very, very difficult for a user to do, which is why there are so few people actually doing recovery testing, because we made that process very complicated in this world of Kubernetes.
I think a few of you have got some comments here.
Yeah, I think the reason you need to do recovery testing is that, yes, Kubernetes gives you a common platform, but there are still some differences in each offering, right? If you're deploying it in AWS, if you're deploying it in GK, things do change slightly. So you need to ensure that, yes, your backups are successful. Are they recovering successfully in all of your environments? Because that's what you need to check and ensure that when there is a disaster, you don't want to, you should not be scrambling on that day to, figuring out what's happening. Okay, I was running on EKS and now need to get things up on AKS and it's not running. So it's very crucial to do this recovery testing.
I would disagree that it's become harder to do recovery testing here.
I'm not saying it's becoming harder. I'm saying we need to do it and ensure that the apps run in all of these, or they are recoverable in all of these environments. It's not hard.
Definitely, yeah. I think in this space there's a bigger focus on automation and how apps are deployed in a consistent manner, such that tools that understand and can do backwards recoveries can understand more about the application when they're doing these recoveries. And so even though the application itself may look more complicated because it's been broken up into different components and microservices, you have a consistent interface to go and perform actions on that application. And so new tools in the space are able to understand what the workflow is for recovery, and therefore you can more easily build automation on top of it, even though there's potentially some more complexity in the application itself.
I'm thinking about, I have some customers where we need to make sure that we are capable of bringing up backups from the last 5 or 10 years or even longer. And all the things that I see is just the recovery plan from losing a cluster is building a new cluster and then deploying the applications on top of it and then restoring the volumes and kind of things like that. I'm really curious how we've solved those issues that come up if we try to restore a cluster with a Kubernetes version like 5 or even 10 years ago, with all the tooling involved to get the deployments done. So that just bothers me a bit, because I think that's the challenges in the future.
Was this customer in Kubernetes?
They're trying to adopt it, even though I think at some point it's not even a good idea to do so if you don't have at least a bit of an answer to that question.
That means we've got a lot more work to do. There you go.
Sure, that doesn't run out.
that doesn't solve the problem right now. All right, guys, thank you very much. This has been a fabulous panel, and let's give them a big hand.
And thank you.
It's all yours, Tom.
All right. Thank you so much to the panel. This was amazing, great content. I to do at least 2 panels, because this is really the best format for these events. Next up, I would like to invite Ron Eakins, who's a Principal Field Solutions Architect in the Office of the CTO at Pure Storage. And I think Ron can explain what he's going to be talking about. A quick shout out to all the people online. Really appreciate the support.
Good afternoon, Valencia. Welcome to my session. So thank you for having us. First time at KubeCon, first time at CNN DB Day. I'm an Oracle person. You've all been told that Oracle's 30 years old and it doesn't live in the Kubernetes world. So I'm going to talk about databases and how SQL databases are still relevant in containerization. So this is me, Ron Eakins, as introduced, Principal Architect in the Office of the CTO at Pure, Oracle Specialist, Subject Matter Expert, been working with data as a data professional for 30 plus years, from a development, sysadmin, database administrator, enterprise architect role. So I've been using data for a long time. I've got 5 patents around data protection and security. The challenges we have in Kubernetes and that panel session there, some of those problems we've had for 30 years, and we've fixed those. So we can actually learn from the experience we've had in traditional databases and apply those to containerization. Oracle Ace Director, so that's a community award. It's not an Oracle job. It just means that, like Microsoft MVPs, VMware is vExperts, Oracle's Oracle Ace program, and I'm an Ace Director, so I'm very proud of that. So today's session, containerized applications and databases, why Kubernetes operators and database Kubernetes operators. We'll drill into those. I've got a very small session today, so I'm going to be quite fast. I normally speak at Oracle conferences, so I normally go a lot deeper. about the Oracle technology, and I'm actually presenting in Kscope in the US next month. So if you go to that event, you can see a deep dive. It's about an hour-long session. But just to introduce databases and operators. Okay, containers and databases. So I don't have to tell you what an operator is. You know, you're all the Kubernetes experts. You know, but what do they do? If we think about it, it's exactly the sort of demands we want for our databases. We want to know where we put them. We want to manage states. We want to be able to start things up. We want to be able to shut them down. We want to keep things up. Load balancing across servers, networking, persistent storage, declarative mode. These are all the tenets of a database. The persistent storage has made databases a reality on containers. And that's what we're going to talk about here. You know, I guess the one takeaway from a database world is, you know, K8's main task is to make the desired state the actual state. You know, when we define the database, we want it to run and we want to know how it's going to run. It's a challenge for the database world. You know, we're used to having fixed names, fixed storage. We know where our database lives. We know where the storage is consumed from. You know, permanent IP addresses, permanent names. That all changes in the container world. So, you know, you're going to have to help educate data professionals like myself what it means to run a database in a container. But why should we containerize databases? You know, it's all of the reasons that you're running stateless applications in containers. You know, it's allowing developers to concentrate on the code rather than the infrastructure. You know, deployment automation. You know, we talk about automation a lot. It's the speed at which we can now deploy. I've been using Ansible now for about 5-6 years, and you know, throughout my career, automation's been a big thing. But what's changed, I guess, in the last 5 years, it's full stack automation. So where we may have had a developer having some build scripts, and maybe a DBA having some backup scripts or some deployment scripts, or a network person having scripts to define firewalls. Now we all collaborate. We build storage, we build networks, we build applications, and we can deploy those via common playbooks. Reduce complexity and system resources. You know, databases are heavy things. They're not really your classic containers. Heavy I/O, lots of network usage, lots of memory. You know, we have to think about the way we deploy applications to make sure that they work in a container world. But the benefits for a database is we can actually deploy more. You know, we get lots of flexibility when we containerize a database. We reduce complexity, reduce the amount of patching, the deployment costs that we traditionally have with a database. You know, it's an enabler to DevOps, CI/CD. We talked about deployments in the last session, about doing releases. You know, people do releases a lot quicker. I've worked on projects where we were doing 18 months for an Oracle E-Business Suite deployment. Now we see deployments every month, every week. It's a lot quicker, smaller releases, but more frequently. Enabler for database as a service. You know, the as a service model is going further and further up the stack. We've started with infrastructure and our platforms, and now we're looking at databases. You know, we see SaaS at the other end, and they're coming together. You know, everything as a service. Portability across environments. You know, there are many clouds, many different environments. You know, we want that portability. We want our application to be able to run anywhere. You know, anyone that works in an application world has to rethink the way they deploy. You know, we got to start thinking as data professionals and IT professionals, it's not about the server, it's about the service. And for me, it's always been about the database service and the data. Now, we're all speaking the same language. It runs everywhere, in the cloud and on-premise. Okay. Why Kubernetes operators? You know, what do they do? What do they give us? A way to package and manage Kubernetes applications. We can ship applications and we know what they look like. Easy to deploy, easy to build. We can move those across clouds. Addressing some of the challenges we talked about with databases being hardwired to server names, hardwired to storage. We remove that. Give these the flexibility to deploy anywhere. Consistent deployment is a big challenge. And that's one other thing that operators give us. The ability to deploy wherever, and we know we're going to get the same results. You need to test it, You know, in the last session, there are differences between some of the clouds. But if we can use an operator, it gives us the best chance of getting a consistent deployment. Test it, make it repeatable, whether that be in the cloud or on premises. This is a screen grab from operator.io. So this is a marketplace for operators. You know, this is just the database category. 38 databases there. And this isn't all of them. This is just people that put their operator into operator.io. And we can see EDB. We can see Pacona with their MySQL and Postgres ones. We've got Postgres there, we've got Postgres there. MongoDB, MariaDB, another Postgres one. There are multiple Postgres operators, multiple MySQL operators, and they're all slightly different, all giving us different services, different features. Makes it quite complex if you have to choose which one to use. So looking at Postgres, the CrunchyDB is a really popular operator. And I think if you go to KubeCon main conference, you'll see that they're there. You'll also see Pacona there, and Enterprise DB. If we look, they all have their own main feature lists. This addresses high availability, it addresses disaster recovery, it addresses advanced configurations. When you choose your operator, you need to make it on a basis of what do you need out of that operator. So you go back to the business, you ask the developer, ask the application owner, what is the application going to look like? Is it a single node application? Is it a multi-node application? Is it over different geographies like the Cassandra application we saw the first thing this morning? We have to actually understand what is the right operator. So you do that by identifying the features and drilling into those, which operator gives you those. And also look at support and maintenance. But it's complex. There's lots of small words there about security, certification. Do you need your database backups encrypted? Do you need secure connections? All of these need to be considered. We've been doing this in the database world for a long time. Now we've got to start distilling that into the Kubernetes world. So, if you're looking for a database as a service, what should you be looking for? Look at the life cycle. Look at the operator. Does it let you provision and delete databases and applications? Probably yes. That's probably the minimal requirement. It can provision something new and it can retire it. And when it retires it, you want it to tidy up. You want it to retire all the services. You want it to remove the namespace, the PVCs. It's got to clean itself up. You don't want to be paying for those resources in the cloud after you've retired that database. So let's have that as the number one requirement. Start and stop services. If you're paying for compute, you want the ability to stop the database if you're not using it. And start it up. Maybe it's a test database. You only have it running during the business hours. So you don't want it running over the weekend. So stop-start services. Advanced topologies. High availability, disaster recovery. Not all the operators do that. So understand your requirements. Understand whether the operator gives you that. Customized configurations. Do you want a Swiss Army knife? Or do you want a tool to do the job you want to do? If you need a bespoke database, you need to go to the application owner, the database owner, and say, what do you configure today? Does your operator allow you to do the same configuration, the same customization, database parameters? Can you define how often the snapshots are taken or where the backup files go? Do you need to care? Not always, but sometimes you do, depending on the database. Scale up, scale down. You know, it's not just NoSQL databases at scale. Something like a database from Oracle can be sharded. You can have that scalable. You can have a cluster database. So we need to consider the same idea about scaling up within the data center, within our Kubernetes cluster. Rolling upgrades and patching. Now this is really important. You know, we talked about Log4j. If you've got a large cluster and you've got business users on that database, you don't want to have to take it away to do an upgrade. You don't want to have to really schedule that out of hours or negotiate an outage. It's becoming harder and harder to get a business outage with applications having been global, 24 demand, customer facing. You might not get that maintenance window. So you need the ability to do rolling upgrades where you can put a new image in place, take one node out, upgrade it, and the database stays up. Your application stays up. So rolling upgrades, rolling patching, looking for that. Database cloning. Database cloning is a really good way of testing your backups and your restores. If you can't restore your database, if you can't rely on the snapshots, then you've got sort of a world of pain. So you clone the database, test it, give it to developers, make sure it's okay. When you start cloning, can you actually obfuscate the database? Can you actually change the database? You don't want to deliver a production database in the cloud to a developer that doesn't need to see production data. So you should have the ability to run scripts on that database before you release it. So this could be emptying workflow tables. It could be removing sensitive data. It could be actually adding manufactured data, synthetic data, which extends the data set for developing and testing. So your development database is the best place to start, but sometimes you need to take some of that out, change it, and maybe complement with new test data. So can you do that during your cloning? Database security. Encryption. You may have storage at rest encryption. But if someone's on that server and they could do a strings attach, can they just shell into your pod and see the data files? Well, that's a scary thought, isn't it? Can they go onto can you shell into the pod and then connect to the database and see all the data? So the practices that we've had in securing our databases and our data sets need to be also included in our ways of working for Kubernetes. So look at your encryption. Is your database encrypted? Is that a database option? Or are you going to rely on the storage platform? What about secured connections from your client? If you're able to query from a desktop to your database, whether that's sitting on on-premise container or in the cloud, is that encrypted, that link? Or can someone just sniff that and see your credentials, your data going past? What about your backups? Are you encrypting your backups? Are you putting them into a clear text format in an S3 bucket? Have you secured that bucket? There's multiple vulnerabilities there. So make sure that you are encrypting your backups. Make sure that your backups are going to a location that isn't public. Know where your data is and know who has access to it. The way we handle our data today is equally relevant in the new world with containers as it is today with traditional databases. Backup and restore. You may be using storage snapshots. You may be using file system snapshots. But can you guarantee you can recover from those? If you're using database vendor backup tools, most of those will test the integrity of the database. If you have just snapshots, maybe there's a database corruption. Maybe you've had a bad HBA and it's done a corrupt block, and you won't know about that block until you actually touch that block, you read it. If you've just got a snapshot, you've got that block there below the surface ready to bite you one day. So it's another reason why to test your backups, to make sure that your backup integrity is good, that you can actually use them. Use backup vendor tools to test the database and the database backups to make sure that the integrity, there's no block corruptions there. Use native backups, complement those with file system storage snapshot backups. Application APIs. Do you have API interfaces? It's great having a point and click, but if you want to go at scale, you need to automate that. So whether that's through things like Ansible, it has modules for Kubernetes, or Terraform, or other tools, you need to be able to call your databases, you build your applications, and automate that. Monitoring login metrics, the observability, being able to actually see what's going on, and actually exposing that. If your database as a service doesn't let you see the audit logs, can you satisfy that audit log requirement from your internal or external audit teams? If they want to say, who was accessing our application at 3 o'clock in the morning? Do you know? Can you see the log files? Can you actually demonstrate that you're in control? Think about that. Think about errors that go in the log file. Is your monitoring tool just talking about CPU use and memory usage, or is it actually saying what's going on at the database application level? Who accessed what data when? We're getting regular errors in our backup scripts. Who owns those now? Is it the Kubernetes administrator? Is it the database administrator? Is it the storage administrator? Make sure you know who's looking at the log files and who owns them. Implement a semi-tool like Splunk where you can actually take all this information and have it analysed automatically for you. But think about where your data is, who's accessing it, and how you're going to be able to report and show that you're in control. Notification services. You don't want to have all this done manually. You don't want John having to come in at 8 o'clock in the morning and the first thing he does, he spends 2 hours looking at all the log files. Have those automatically scanned, security logs, access logs, and notifications going out if there's anomalies. Whether that be physical, virtual, containerized, or on-premise in the cloud, the same disciplines should be there. We should be looking at managing our data consistently. We shouldn't have one team which works in one way for containerized databases and another one for our traditional physical databases. The data is what people are after. We talk about ransomware and mitigating that, protect your data. So I've been using operators for a while now, and I've done several blogs. I talked about using the EDB Postgres. I really like this one, a good operator, so have a play with that one. I've documented how to install it. That's very much a walkthrough, so you can have a look at that one. I've done one on Yugabyte DB, and that's interesting as well, because that's a distributed database. So that gives us even more challenges. If you have your data spread over different places, and it's designed to actually be fault tolerant, where you can lose a geography and the data is split around. It's built. The data protection is built into the database. So look at that one. And also, Oracle is the #1 commercial database, but MySQL is Oracle's #1 open source database. So I've got something on there. And when people talk about databases and Oracle, Oracle's now coming to the party. So the Oracle database for Kubernetes operator is available. It's in early release. I don't work for Oracle, but I am using this as part of the beta program. And what we're doing here is we have Kube Control, being able to manage databases, whether they be containerized or traditional databases. So this is really powerful now. We can have one language, we can manage all of our databases. And I think this is the way we're going to be going, because we're not going to be putting all our databases in containers anytime soon. It took 10 years for DBAs, Oracle DBAs, to move their databases into VMware. They may move quicker with containerization, but it's not happening next year. I'm seeing a few people do it, but not many. The way you install the operator is the same as any other operator. Pull the image and apply it. Take your YAML file, configure that, localize it, put the database name, the namespace, the database name, the PDB, the CDB names, where you're going to be pulling the information from, the images, the secret, all of the information that you would normally have in a YAML file, put that in there for the database, and then apply. And there we are, apply it, and that will build as a database. And then from a DBA, from an Oracle DBA's point of view, to Oracle developer's point of view, it looks and feels the same way as a normal Oracle database. And that's it. Got a database up. I have got a demo. I'm not going to do a demo now, but I am going to be around for questions. We were tight for time, and that's me done.
All right.
I don't think I'm going to have any time for questions. But if there is any, please grab me over a coffee.
I'd suggest we take that offline, because we're on a tight schedule right here, and we would like to have Tom Manville on stage, VP of Engineering here at Custom by Veeam. We like to save the best for last. That's a joke. Always helps explaining it. Thank you so much. That was a great presentation. Thanks, Ron. All right. So I again would like to thank everybody. Would like to thank the sponsors, Custom, Portworx, and our friends from Evaluator Group for making this all possible. I think this was a great event with really good content. Thank you to all the people online as well. Food was amazing, I think, that too. And Tom, you're going to take it from here, right?
Hey, everyone. Can you hear me okay? Too well? Great. I'm very excited to be here. I think everyone is really enjoying the in-person interactions, and so I'm definitely part of that group. I know this is the last talk of the day. You know, we had some amazing lunch, and so I don't want to make people online jealous, but it was very good. Some great croquetas and other great food here. Thanks everyone so far for all the talks and the panel. I think that I really enjoyed listening to those and hearing about what's going on in the field. And you know, I really just missed this, so thanks everyone for being here. So what I want to talk about today, I don't know if this, there we go. I want to talk about stateful applications in Kubernetes. And my focus today is going to be on what makes the cloud native ecosystem a little bit unique when thinking about stateful applications. So this is obviously not complete. I think there's a lot of things that you have to consider when deploying stateful applications. But as we go through this, you know, hopefully you get some insight into the different things that you'll have to think about as you deploy your stateful apps. Great. So I'd like to start with the definition of cloud native from the CNCF. So if you've seen this before, hopefully it's not too repetitive. But the basic idea is that this is really the modern way to deploy and use applications. It kind of also captures the idea that these new environments are very dynamic. And often that poses many challenges when deploying stateful applications because of this dynamism. There are many, many projects in this space, so I have an eye test for you. Can you read anything on here? Probably not. I think you know, this slide is a bit overwhelming sometimes, but really what I want to emphasize here is that there's a big community aimed at helping people solve all the different problems you can imagine, right? So across the board, when you're running infrastructure, I think there's something in the cloud native space that can help you meet your goals. What I also want to talk about is shifting left. So shifting left is one of the fundamental paradigms in this space where you start testing your application much earlier in the development process. This is really important because you find issues earlier and you're able to deploy much more quickly and get continuous feedback from your deployments of your product. You know, this has made companies very successful, and I would say it is actually a requirement of running applications today. You know, we had some great talks today on the implications of security on your applications, and I think shifting left is definitely a requirement these days. Otherwise, you're going to have long-standing vulnerabilities that you need to patch. Right? There's many famous examples in the field of times when people didn't patch their systems, and then they were hacked, leading to very, very bad consequences. In this space, the way that I like to break down on how the cloud native ecosystem has really changed the way you think about your stateful applications is portability, right? And I think there's some best practices you can follow to ensure that your applications are portable and get all the benefits from that. So when your applications are portable, you really are able to leverage kind of all these different projects in the community that will help you deploy and make your applications robust and secure. When I think about portability, there are really kind of three main components of portability that I would consider. So the first one would be your source code. When you build your source code, right, you want to be able to deploy it somewhere. For the most part, through containerization, this ecosystem has really been able to make your source code portable. So you know, you're able to build containers and run them kind of anywhere. I think the way that this ecosystem struggles a bit sometimes is when you are trying to run your code in environments that don't have different architectures. So for example, you know, running on your Mac locally does pose some challenges. Although I would say that through virtualization, people have been able to run these containers locally during this shifting left in their dev process. Another area to look at is applications. So in Kubernetes, most applications are defined through a common set of APIs. These APIs, you know, we're all familiar with the YAMLs that we've seen for defining what an app looks like. This is really good because it means that I can define these YAMLs in one place, and that I should be able to deploy them in multiple environments. However, I would say that the Kubernetes abstractions don't encompass everything your infrastructure can expose. And so in many occasions, there are useful features from your infrastructure. I can give an example. There are snapshots in EBS, for example, that are exposed through the CSI, which is the Container Storage Interface, which is how Kubernetes consumes and exposes storage. And copying between different regions is not exposed through this API. So therefore, if you want to do a copy, which is a very important workflow in data protection workflows, then you will have to go under the covers below CSI, and break the abstraction. And there are many examples that we see like this in the space, where if you really want to do things robustly, you have to break through the abstractions a little bit. And so that's definitely a challenge in the space, which people are working on, certainly. The final one is data. And I think the biggest portability challenge with data is the weight and the gravity of your data. If I have something on my local machine, it's not instantly accessible from somewhere else. And similarly, if I have a machine in the cloud, if I'm using local storage and there's some disaster, I don't have the option to consume that storage immediately from somewhere else unless I put a disaster recovery plan into place, which is very important for running stateful applications. When you think about your applications that consume different types of data, it's useful to frame them as a data service. And when you want to consider moving your data around, the way that I think about it is the different types of consistency you get. So by default, many applications and many databases support crash consistency. So if there's some type of failure, you can go and immediately restore that data. Maybe there's some transaction log that your data service will go and apply, but even if you have a crash, you can come back to some consistent state. That's very useful, but only if you have some isolated failure domain that you don't have to extend beyond. So the other kind of consistency that we describe, which is somewhat new in this space, but I think applies to even legacy systems, is application consistency. And what this means is that you have to coordinate between multiple components in your application. So potentially, let's say your volumes, right, do like a freeze, unfreeze, your data service, so like if you're using like MySQL, flush tables with read lock, to get a holistic view and a holistic crash consistent view of your application. Of course, the most portable thing you can possibly do is capture data at the logical level. So this would be something like doing a MySQL dump rather than grabbing just data from the volumes. Of course, in many cases, this is the only way that you can take backups of some systems. The example that I think of would be RDS in AWS, where if you want to actually extract data and move it to somewhere else, you'll have to take a logical backup of that system. Of course, the Kubernetes community is very active in this space and trying to address all these issues or make it possible to address them. So there's a lot going on this slide, so don't dig into the details. But this kind of captures a lot of the efforts, most recently, that the Data Protection Working Group, as part of SIG Storage, has been trying to work on. Of course, this group is one of the most popular, SIG Storage is one of the most active and popular groups in the Kubernetes ecosystem. And there's lots of issues that different people are trying to address here. So this slide actually comes from the white paper that was recently published, which kind of gives a scope of what is available for data protection in Kubernetes. And then, of course, the components that are still in progress or missing from Kubernetes, and in some cases don't even make sense to be in a Kubernetes API. The hope is that once all these components have been worked on and are a little more full-featured, you'll have to break the abstractions of Kubernetes a little bit less. But I think the key takeaway here is that there are many things that you'll have to manage on your own or go to a vendor outside of Kubernetes to work with. Of course, there was actually a talk planned today, which I think we have a recording for, so we'll be able to go back and watch online afterwards. But I do encourage you to check it out. It gives an overview of the white paper and dives into more details on what's going on in the space. I wanted to dig into how I think about data protection. And we've all heard the 321, 32111, 32110. It's a little bit overwhelming, and I think the most important thing there is to really think about what that means. And for me, what that means is that you want to mirror your failure domains. So if you imagine that infrastructure goes away, what's your response? How do you respond to that? And so for me, what that means is that you have to do a recovery in light of the fact that some failure domain is not accessible. And I'll dig into what that means a little bit. So people are familiar with traditional cloud failure domains, but I want to talk about what it means inside Kubernetes specifically. So if you have a node and your node goes away, a node is only one component of the state in your system. If I have a volume that's attached to, let's say ephemeral storage or something like that, or local storage that's only accessible from that node, your node goes away, that storage also goes away. And so that would be a case where you've completely lost your data, and you have to make sure that you have backups for that. In most Kubernetes systems, people are using more distributed types of storage. So in AWS, I'll keep using AWS as an example. In AWS, EBS, for example, is distributed, and you can access that storage within an availability zone. In the Kubernetes space, that may map to a single cluster, and if your cluster goes away, you would then lose that, and so you need some other strategy which will let you go and recover that data, even if it extends beyond a single availability zone. Or in the on-prem example, that would probably map to data center. In Kubernetes, there's also namespaces, which are a logical isolation unit. And if you lose your namespace, you may want to just do a local recovery in a different namespace. And so when you take a backup of something within a namespace, having the ability to copy applications is very useful for protecting against namespace losses. Typically, a namespace loss it would be something like a operational error, right? I accidentally went in there and I deleted some objects that I need, and so I want to do a test recovery or do some actual real recovery into a different namespace to make sure things work. Finally, as we all know, I think that the scope of Kubernetes is getting bigger and bigger. There's some great discussions today on multi-cluster. I would say that the cluster is actually kind of the final Kubernetes-specific failure domain, and a cluster can only exist in one provider at a time. People are now addressing multi-cloud strategies, which will let you have clusters across different providers, and you want to make sure that you understand the failover mechanism to different providers. There have been cases where entire regions in AWS have gone out, and people want to move between different providers. In addition, I think we see providers in a few terms, right? So even if you're on-prem, for example, doing a failover to on-prem or vice versa in public cloud is also a very useful data protection primitive. I wanted to kind of walk through an example of the different domains with more specifically with a few better diagrams. So what I have here is just a namespace, and you can actually do an in-place restore in Kubernetes. So when you're doing restore, you can overwrite your config and data in place, and that's actually pretty useful for a few reasons. One of those reasons could be, I have some critical error and I want to do a rollback. Rollback is pretty common. We see that a lot in people's data protection strategies. It's also useful if you want to do something like you want to roll back Kubernetes versions. So people do cluster upgrades. Sometimes there's some APIs that maybe have changed or are no longer supported, and they have to roll back their cluster and then roll back their data as well because there's some corruption that they might want to deal with. The next kind of primitive that people use is a clone between different namespaces. And this is useful for many different reasons, right? There's a lot of testing things you can do. Potentially namespaces are tied to availability zones. If you want to have more local state, you can do a clone between different namespaces and do your testing or do your failover between different availability zones. And finally, I think the last primitive is between clusters. And when you do a recovery between different clusters, there's many different reasons for that, right? I think this opens up kind of the whole possibility of approaches you can do. You can do copies between different providers, between different Kubernetes versions, between different distributions. I think it all comes into play here. However, with these different environments that you back up and recover into, there are other considerations you need. And the way that I think about this is really to understand the Kubernetes application definition. So you have to do transformations potentially on both your data as well as the application definition. And so it has to be incorporated into how you deploy your app. So if you're using GitOps, for example, GitOps is the thing that contains your entire application definition, and may tailor that definition to different environments. And those environments could be, again, Kubernetes versions, distributions, or even different providers. What's interesting, I think, is that when you do these recoveries, right, you may need to do some kind of transformation between different things. And so, again, as we've discussed today, make sure that this is automated. And so what I have here is an example from a backup and restore of changing something specific to your environment. And this example is actually changing the storage class that you're using. So this could apply to actually any of those use cases I mentioned before, where I want to do an in-place restore, which could upgrade my storage that I'm using. It could be between different providers, or maybe between different environments within the same provider, where the storage class isn't available, or even between different providers, where the storage class cannot even be deployed, so I have to modify it. And the specific example is modifying the deployment spec, the volume claim. And although that is a common API, the parameters you pass in there are not common across all these environments. And so I wanted to leave this open for questions and kind of discuss any challenges that maybe people in the room have faced here, and give, I think we should take advantage of this in-person interaction. So hopefully, you can give me some hard questions while I have this chance. But if not, going once, going twice, awesome. Well, thank you, everyone. I really enjoyed today, and I'll see you soon. Thanks. Thanks, Tom.
All right, thank you. Happy to end on time. I want to thank the audience for being here. I think it was a good event, a lot of good content, good conversations. Thank you again to the panel as well. Thank you to the sponsors, and I hope you'll all be having a great KubeCon, Cloud Native Con. Any follow-up questions, send them to the CNDM team on Slack or by email. There's the website. And our next event is at We Are Developers in Berlin in June, 14 June, that is, I believe. And then we'll be back in Detroit in October, that is, I believe. So anyone who wants to participate, send us abstracts. If you want to sponsor, let me know. And again, thank you all for being here. This was a great event, and have a great KubeCon.